Hi all, welcome to CodAffection. In this video, we'll build a complete authentication system covering user registration, login and authorization using an Angular client and an ASP.NET Core minimal web API. The implementation is based on ASP.NET Core Identity and JSON Web Tokens. The part-by-part video series is already uploaded on this channel. In this video, everything is combined into a single complete walkthrough, and all issues related to the latest Angular versions have been fixed. Along with building the project end to end, we also explain all the key concepts and underlying theory with clear illustrations, so you understand not just how things works, but why. The full project is available on GitHub. Each section has its own repository, allowing you to track incremental changes throughout the development process. This video will give you a strong practical foundation for implementing authentication and authorization in real-world applications. So make sure to watch this video till the very end. Before starting this video, I would like to ask you a favor. If you find this video helpful, please show your appreciations through your likes and shares. And if you haven't subscribed to the channel yet, please consider doing it now to get notified when I upload new videos. Without further ado, let's get started. So first of all, we are going to design the user registration form in Angular, and then we can implement the counterpart in .NET Core Web API with ASP.NET Core Identity. So let's start with creating the Angular project inside this folder directory. For that, we have to execute an Angular CLI command from this same folder. If you are in Windows, you can do this. Just replace this folder path with cmd, then hit enter, so that this command prompt will be opened from the same folder directory as that of this folder here. Now to create a new Angular project, you can use this Angular CLI command ng new. The name of the app will be Auth.EC. Inside this Angular app, we are dealing with the client side, so I will name this app as Auth.EC client. If you want to know more about this command, you can go to the official documentation at angular.dev. Inside this references, go to CLI references, and then you can see the command here ng new. Ng new, then followed by the name of the app, will be passed as an argument, and then if necessary you can configure it further with the options here. All of the options could be seen inside this side panel here. For example, consider the 4 files for the default Angular app component, for which we have the original TypeScript file, it can't be ignored, and then we have the necessary HTML file for designing the component. Rest of these files for style sheet and this test file with the extension spec.ts are optional. So in order to tell the new Angular app that we don't need this component specific style sheet and this test file, we can make use of these options here. So this option here, inline-style, will help you to prevent from creating component specific style sheet throughout the app. Now let me copy this option. While passing the option, we need to use double hyphen as a prefix and then pass the option. For some options, you could see alias like this. Instead of passing this complete option here, we can use this alias small letter s. In that case, we only need to pass a single hyphen as a prefix. Now, in order to prevent from creating component-specific test files, we can make use of this option here, skip test. In short, we can use this alias capital letter S. So here we go, capital letter S. Now finally, in order to skip from initializing the GitHub repository, we can make use of this option. In short, we can use this small letter alias G. Now hit enter. Which style sheet format would you like to use? I will stick with CSS. Do you want to enable SSR and SSG? Press N for no. Wait for some time. It is creating the new project and installing the default npm packages. It will take time based on your internet speed. Finally, here we have done with the creation of the new Angular app. Now let's navigate into the project folder. Now let's open the same in VS Code. For that, you can use this command code space period or dot simple, hit enter. So here we have the new Angular app open in VS Code. Now before making any changes inside this new app, let's run this app. So go to terminal, then new terminal, then run this command ng serve then -o. It will build the project and open the same in your default web browser. So this is how the default Angular app looks like. Now back to VS Code and let's check from where does these default elements are rendered. So here we have the src folder. Most of the app development will be done inside this folder. Already installed npm packages and dependencies will be listed inside this package.json file. All of the TypeScript configuration will be there inside these 3 tsconfig files here. And rest of the Angular related configurations will be there inside this angular.json file. Now everything starts from this main.ts file. As you can see, the default app component is used as a wrapper for the entire application. And here we have the index.html file. It contains the HTML declaration and then the head and body tag for the entire web app. Here you could see the tag app-root, which is the selector of the default component app component. You could see the exact component here. See this TypeScript file representing the app component. There you could see the component selector app-root. The same is mentioned inside this index.html. So in place of this component selector, the corresponding component HTML file app.component.html will be replaced. Whatever is there inside this component specific HTML file will be replaced in place of this selector here. So that's what we have seen inside this app by default. Everything inside this default app is rendered from this component HTML file here. Now you may already know this, from Angular 18 onwards, the default app is configured for standalone components. Before Angular 18, by default, the components were organized into modules. So there was a TypeScript file representing the default module as app-module.ts file, in which we were importing the necessary dependent external packages or services and the containing components inside the module. Instead of components organized into modules, here we have a standalone component. So there is no app-module.ts file. Each component will import all of the necessary things into its component decorator, as you can see here. So that's a major difference starting from Angular 18. Still, if you want, through changing the app config, you can go back to the previous module-based architecture. Now we have to start customizing the app from this app.component.html file. Now before getting into that, let's talk about the structure of the app that we want to build. For that, I'm going to create a new file. I will name it as app.structure.txt. I have already prepared this structure. Let me paste that here. For now, we are going to create a parent component user. Inside that, we'll be having two components, one for login form and one for the user registration form. And then inside this shared folder, we'll be having global entities required for the entire app development, like services and pipes. For now, we'll create this auth service, which is required for consuming the .NET Core Web API that we are about to create. The listed pipe will be created later. Now from this app structure, let's create whatever we needed for implementing the user registration. For that, first of all, open the terminal. First of all, let's create this parent user component. So here is the corresponding Angular CLI command, ng, g for generate, c for component, and we have to provide the name of the component, which is user. You can see the corresponding documentation here. Look for ng generate. The command for creating the component could be seen here. Now hit enter. You could see the newly created component inside this app folder. See, we only have two files, one for TypeScript and one for the HTML file. It's due to the initial configuration we have provided while creating the Angular app. No component specific start sheet and no test file. The specified configuration is saved into angular.json file and will be applied for every component that we create inside this Angular app. Now let's create this component for user registration. For that, we can reuse the previous command. Just use the upward arrow so you can see the previous command that we have used. this registration component should be placed inside this folder, user component folder, because it's a child component for this user component. So user/registration. Hit enter. So here we go. Now this login component will be created in next section. So I will just mark it as like this. Now let me create this auth service. So here we go, ng g for generate, s for service. We want to create the auth service and we want to place this service class inside this folder directory shared/services. Hit enter. So here we have the new service class inside the specified folder path. We will be creating this pipe later. So that's all enough for now. Let's start customizing the app for user registration form. So let's start with app.component.html. I will replace everything inside this file. Instead, I want to show this parent component user. So you could see the corresponding selector here, app selector, app-user. So here we go. Let's create a tag with the selector like this. So currently inside the app we have the default text from the user component. You could see the same inside this user component HTML here. Now before going forward with the customization, let me add the Bootstrap into this Angular app. So go to the official website getbootstrap.com. From this home page, I will just copy this statsheet CDN reference. And let's paste that inside this index.html inside this head part here. And I also want to use the Google font for this app development. So go to Google font, then search for the font Indo, which is my favorite Google font. So here it is. Click on Get Font, then click on Get Embedded Code. Let's copy these link references and just paste the same inside this head part here. Now we want to apply this font for the entire application. So open the global stat sheet styles.css. Inside that, we will apply the font for the entire body of the HTML web app. Let me copy the CSS rule from here. Font family is applied as Indo and there is a backup sans serif. So that's all about adding Bootstrap and the Google font Indo into this application. Now back to the user component HTML. And let me detach this app preview and let's place it side by side with VS Code. Now inside this user component, we want to show this registration component here. For that, first of all, we will have the container from Bootstrap. Inside that, we will have the raw div. Now in order to render this registration component, we can add the corresponding selector that will be app-registration. Now here you could see an error saying that the app registration is not a known element because currently we are dealing with standalone components. So everything that we are going to use inside this user component should be added into this imports array here. So here we go, registration component. That's it. Now we are showing the default text from this registration component here. Now back to the user component again. Now I want to show this registration component inside a card-like element. For that, here we have an extra div having this class from Bootstrap rounded 4 to apply a corner radius. Let's set the border width to 0 and we want to apply a shadow and the background color will be white. Now let's move this component into it. Now at the same time, I want to apply a different background color for the entire body of the app. So back to index.html. For this body here, I will apply this Bootstrap class bg primary settle. Back to the user component. Now let's render this div. For that, I will apply the vertical height of this raw div to 100%. To align the containing child in vertical center, we can apply this class align item center. Now while developing this app, we may need to expand or decrease the width of this preview. So let me wrap this div with another div having the responsive classes. So here we go. Let's move this div into it. Okay, that's fine. Now let me set a minimum height for this div using the style attribute like this. Min height is equal to 450 pixel. Now we want to apply a padding before this registration component. So here we have another div having these clauses, and along with that we want to apply 100% width. That's it. Now in order to place this div at vertical center, we can add another wrapper div like this. First of all, we'll set the display to flex, and then we can set this justify content start. Now to center the containing div at vertical center, we can apply this clause align item center. So that's all about the surrounding wrapper for the registration form. Now we can design the registration form inside this registration component here. Let's create the form using Angular's reactive forms approach. You could see the detailed documentation here. Go to docs. Then inside this forms, you could see reactive forms. Here you could see the different ways of creating forms in reactive forms approach. In this video, we'll be using form builder from the reactive form module. So first of all, let's go to the component TypeScript file, and then we have to import this module, reactive forms module. And then we can inject the form builder to this class constructor. Public form builder, which is of the type form builder. There is a correction that I want to make regarding this constructor level injection of this form builder. We'll discuss that in a bit. Now with this form builder, we'll be creating an instance of form group. Inside that, we'll be defining properties corresponding to form controls. So here we have the form group object form. Now to create the form group, we can make use of this form builder. From that, we just need to invoke this method group. Into that, we can pass an object like this. Inside this object, we can add properties representing each of the controls. So first of all, we have full name of the user. Into it, I will just assign an array like this. So this first item of this array will be treated as the default value of this full name control. Now into this array, we can append various validations that we want to apply to this full name control. We'll do that once we implement the .NET Core Web API project. Now let me duplicate this for email, password and confirm password. Now here is the correction. We have injected this form builder at constructor level, and we have used the same form builder to initialize this class field form. Now here is the thing. With latest version of Angular, especially after Angular 18, the initialization of the class field will be happening even before the constructor level injection. So when that happens, during the initialization of this form field, the form builder object will be empty. That will result in the error property form builder is used before its initialization. To avoid that, we can do this. Instead of injecting it at constructor level, create a field like this form builder and do the manual injection using the method inject like this. Okay, that's gonna solve the problem. So make sure to do that if we want to use the injected objects for initializing the class fields. Since this is a future update, I'm gonna stick with the constructor level injection, but you should do this manual injection. Okay? Now we can design the form using this form group object. So back to the component HTML file. So first of all, we have the form element. We don't need this action attribute. First of all, to this form element, we'll set this directive form group. Into that, we can assign the form group object that we have just created. Now first of all, let's add the input control for full name. For that, first of all, we have this div having a bottom margin of the range 3. Inside that, we can have this input element having these bootstrap clauses form, control, and with this class, we'll apply a background color bg body secondary. We don't need to explicitly set the type attribute as text. The default value is text itself. So let me remove this type attribute. Now here I will set the placeholder as full name. Now we have to bind this input control to this full name property of this form group. For that, we can make use of this attribute form control name, and we just need to set it as full name. Now let me copy paste this for email. The corresponding property is email. The placeholder will be email. Sorry, something is wrong with this text box background color. Yes, here we have a typo. Now let me copy paste this for password. The corresponding property is password. And let's change this placeholder. If you want to hide the characters entered into this text box, you can set the type of this input control to password. Since we are creating this project for demo purpose, I will skip that. Let me copy paste this for confirm password. Now finally, we have to show a submit button. So here we have the div having a top margin of the range 4. Inside that, we can have the button of the type submit. And let's apply these bootstrap classes btn, then btn success. And this button will be having 100% width. And let me modify the corner radius to this class. Inside that, we'll show this text register. So that's all about designing the form. Finally, let me add a heading for this form. For that, we can have this div having a bottom margin of the range 4. Inside that, we can have an h2 element, and let's set the containing text color with this class text success. Inside that, we'll show this heading sign up. Now let's implement the form submit event to ensure that all of these form controls values are getting posted properly. For that, we can make use of this event property ng-submit, and let's assign a function to handle the form submit event. So that will be on submit. Now we have to define this function inside this TypeScript component here. Now inside this form submit method, to retrieve the submitted form data, we can make use of this form group here. So here we go, we'll print the form data into the developer console. Using this form group, this .form.value will return the object having the values from these form controls. Let me save this, back to the app. Let's open the developer console. Let's populate the form with random data. Submit the form, boom. So here we have an Angular registration form ready to submit the user registration data into the ASP.NET Core Web API. So let's go ahead with creating such a Web API using ASP.NET Core Identity Framework. So without further ado, let's get started with creating the Web API project inside this Visual Studio 2022. So first of all, create a new project. Select this template ASP.NET Core Web API. I will name this project as Auth.EC API. Click on Next. Then select the latest installed .NET version. Then I will keep this authentication type as none so that you will know how to implement it from scratch. Now since we have a demo project here, I will uncheck this HTTPS configuration. Then I will keep this feature OpenAPI support as it is. This feature allows us to make use of the Swagger tools for testing the various endpoints that we create inside the Web API project. Now click on Create. So here we have the brand new Web API project. Before we go any further with ASP.NET Core Identity inside this project, first of all I want to talk about Identity and Access Management, abbreviated as IAM. Throughout this series, I will squeeze in as much as prerequisites like this to make you familiar and comfortable with ASP.NET Core Identity. So in short, IAM ensures the right people or machine or software components get access to the right resources at right time. Now, when it comes to authentication or authorization, it might not be always a person trying to access a secured or protected resource. It could be machines, for example, robots, and it can also be a software component. Now assume that you have a client-side app in Angular or React. And inside that app, say you want to retrieve all of the Facebook groups that a particular FP user has joined. For that, first of all, this client-side app must be authenticated to the Facebook developer auth system. In this given context, instead of a person, we have a software component that is trying to access the Facebook API. Instead of a normal FP user credentials like password with email or mobile number, this software component should be passing a different credentials which is first registered into the Facebook developer system. So in this given example, the client-side app acts as a software component. So in short, the party that is trying to access the protected resource could be anything in this range: people, machines, or software components. So IAM ensures that the right party get access to the right resources at right time. In brief, first of all, the party must prove that who they are or what they claim to be. A process in which they have to prove they are an insider. This is what we call authentication. This process in layman term we often call as login or sign-in operation. Now let's go ahead with the next step. Even when a party is successfully authenticated into the system, proving that they are an insider doesn't mean that they have the full access to consume the entire resources inside the protected system. The party could be allowed or denied to access certain resources inside the system. Now, this process is called as authorization. So a solution that fulfills these requirements is globally known as Identity and Access Management, in short IAM. For .NET applications, these are the available identity management solutions. Among them, ASP.NET Core Identity is the commonly used identity management solution for .NET Core applications. Now let's get straight into ASP.NET Core Identity. Now before getting started, I just want to let you know that the official documentation of ASP.NET Core Identity could be seen under this ASP.NET Core documentation inside this section, Security and Identity. And make sure to select the right .NET version from this drop-down. You could see the link of this official documentation inside the video description along with other important resources that I have referenced for this entire series. Rest of the prerequisites could be discussed when the right time comes. So with that being said, back to the Web API project, and let's look what we have inside this default Web API project. So everything starts with this Program.cs file. So first of all, we have a builder object returned from invoking this method createBuilder from this web application class. Inside the builder object, we have this service collection. Into that, we'll be adding services that we need inside this Web API project. And from the same builder object, we have invoked this build to return the app object, which is then used for configuring the services that we have added into the service collection here. Okay, you could verify that here. As you can see into this service collection, first of all, we have added the controllers that transform this application into a Web API project. Otherwise, this would be a plain C# console application. And then with this app object, we can configure the services that we have added here. So for example, we have called this method map controllers so that all of the endpoints inside the various web methods inside this application will be configured into this project. Similarly, we have added the services for the Swagger UI here, and the same is configured here. Along with all of these methods, we have invoked this method use authorization. We'll talk about that later. And finally, with the execution of this run method, the entire application will be made available to accept the incoming request. So that's all we have inside this project. Now it's time to add ASP.NET Core Identity into this project. We have already discussed what is an identity access management and what it does. So the same is applicable to ASP.NET Core Identity also. Now let's be specific about what it does. ASP.NET Core Identity includes APIs, UI, and backend database configuration. So basically it allows us to manage user identities, storing user credentials, and granting or revoking permissions. Now along with these primary requirements, it supports external logins, two-factor authentication, password management, account lockout and reactivation, and support for authenticator apps. So all of these features are made available by ASP.NET Core Identity to the outside world through the APIs here. We just have to consume them with the required data passed to it, which are basically web API methods. Now when it comes to a web application MVC, it also provides the front end with Razor pages, which I have already discussed in one of my previous video. Link will be there inside the video description under the heading related videos. And finally we have the backend database configuration, which is basically Entity Framework Core models. So throughout this series, we'll be discussing how to make use of these services provided by ASP.NET Core and how to customize them as per our requirement to implement all of these features here. Now it would be more helpful if we understood the architecture of ASP.NET Core Identity in brief. We'll come to that in a bit. Before that, let's install the required NuGet packages into this web API here. For that, right click on this project, then manage NuGet packages. Then inside this browse tab, search for this package, Microsoft ASP.NET Core Identity Entity Framework Core. Throughout this series, the install NuGet packages name will be there inside the video description along with other helpful instructions. You just have to copy paste from there. Now let's install this Identity Entity Framework Core package. Now since we are going to use SQL Server for this project, we have to install the corresponding Entity Framework package, which is Entity Framework Core SQL Server. Let's install this. Now finally, in order to execute the migration commands, we have to install this package, Entity Framework Core Tools. So these are the NuGet packages to get started with ASP.NET Core Identity. Now let's add the corresponding services into this Program.cs file. Like this default project added the service for Web API controls. Now before doing that, let's get familiar with the architecture of ASP.NET Core Identity. So first of all, we have the data source layer for storing the data related to the entities inside the framework. In our project, it would be a SQL Server DB. Then we have data access layer. By default, it would be Entity Framework Core. And then just above that, we have Identity Store. It defines the structure and relation between various entities inside the identity solution. You could think of them as entity framework models, like users, rows, etc. All of them defines the ultimate structure of the table that is going to be created inside the data source. And then we have Identity Manager. For each entity we have inside the solution, such as user or rows, we have corresponding managers like user manager, role manager. So basically they consist of methods or handlers to implement the features that we talked about, like creating users, authenticating, authorizing users, etc. and etc. So these are the two layers that comes from ASP.NET Core Identity. Now in order to make use of them inside our ASP.NET Core Web API, we just have to add the corresponding services into our Web API project. So here we go, builder.services. First of all, we have to add this identity API endpoints. So this will add the various API endpoints from the identity core, which are handlers to implement various features that we talked about. Now while invoking this method, we have to pass the model class corresponding to the user entity. So that will be identity user. So by default, this is the class identity user, which defines what all things we need inside the entity user. So here you could see the default properties inside the user entity. We'll customize that in a bit. So first service is added here. So the service that we have just added is corresponding to this identity manager and the corresponding exposed web API methods. Now let's add identity store. Let me zoom in a bit. For that, we can invoke this method add entity framework store. So these are the two services that we have to add to make use of the identity core. Now while invoking this method, we have to pass the class corresponding to the DB context that we are going to use to interact with the DB, which we have not yet created. So let me create a new folder called models. Inside that we can have this class app DB context. Normally, in order to define a DB context class, we inherit this entity framework class DB context. In case of Identity Core or ASP.NET Core Identity, we have to make use of this DB context class, Identity DB context. Now this becomes a DB context class. Now let me copy this and let's pass the same here. So here we have done with adding services from ASP.NET Core Identity into this Web API project. Now using the model classes that we have inside this identity store, let's create the actual physical DB inside the SQL Server. For that, we can just continue with the DB context class that we have just created. Now first of all, let's add the constructor like we used to add in any entity framework called DB context. Now here we have the corresponding parameter DB context options. Now we have to specify the DB context class as app DB context. Let's name this parameter as options. Now along with this constructor, we also have to invoke the base constructor, which is the constructor that we have inside this parent class here. For that, we can do this base then options. Now in order to create the physical DB with the existing default entities inside Identity Core, we have to do the migration. Now by the way, these are the entities that we have inside ASP.NET Core Identity. For each of these entities, you could expect a SQL Server table. Now before doing the migration, we have to inject an instance of this DB context class inside this Program.cs file. So here we have the service. From that, we can call this method add DB context. Now if you don't know how dependency injection works, we can explain that in brief in a bit. Basically, it is a process of creating an instance of this passed class here. So in order to create this instance, we have to pass the argument corresponding to this constructor parameter here. So basically, it is expecting a DB provider based on the DB that we are using. So we'll pass the argument using this lambda expression. All we have to do is from these options, we have to call the method corresponding to the DB provider that we are using. Since we are using SQL Server inside this project, we can invoke this method use SQL Server. Into that, we have to pass the corresponding DB connection string. So first of all, we have to save that into this app settings.json file here. So here we go, connection strings. Inside that, we'll have this key dev db. So this connection string is only for the development environment. So first of all, we have the SQL Server instance name, and we have the DB name, which is auth ecdb. And then we have these options. First of all, trusted connection is set as true. Now in order to enable the encryption, we have set this option as true. Now finally, in order to execute multiple query batches simultaneously, we have set this option multiple active result sets. So that's all we have inside my DB connection string. Now let's pass this same into this use SQL Server method. In order to access the data that we have stored inside this app settings, we could make use of the builder object like this, builder.configuration. From that, we can invoke this method get connection string. Into that, we can pass the name that we have given for the connection string. Now we are ready for DB migration. Now before getting into that, let me briefly explain how dependency injection works in ASP.NET Core. So here we have injected an instance of this app DB context class. And here we have the default controller inside this app weather forecast. Inside that, you could see this default web API method for a get request. The instance of this class here, this controller class, will not be created as by manually. It will be automatically created by the ASP.NET Core framework when a request reaches up to this web API method here. So during the creation of such instances, if the corresponding class constructor is having a parameter which is of the type that we have injected here, then a corresponding instance will be assigned to the constructor parameter that we have here. Say for example, for this constructor, we have a parameter of the type app_db_context. When an instance of this controller class is created, an instance of this app_db_context will be passed because of this dependency injection here. We don't have to create the instance manually. So that's how dependency injection works. Now let's go ahead with DB migration. Before that, build the project. Make sure that there is no error. See here we have a successful build. Now all we have to do is open the package manager console, which in my case it is inside this bottom portion of the Visual Studio. If you can't see it, select the project, then go to Tools, then NuGet Package Manager, then Package Manager Console. Now for DB migration, first of all we have to execute this command add migration, then provide a name, let it be initial migration, hit enter. As a result of this command execution, here we have a new folder called migrations. Inside that you could see the C# file with respective SQL Server commands which is to be executed to create the actual physical DB. Now in order to create the actual physical DB, we have to execute this second command, update database. So here we have successfully done with the migration. If there is any problem in connecting with the physical DB, you could expect an error while executing this second command. So if there is any error, please recheck your DB connection string. Now in order to work with the database, I will be using the SQL Server Management Studio. Let's check whether the actual physical DB is created or not. So here we have the new DB. Inside that you could see the tables corresponding to the entities that we have inside ASP.NET Core Identity. So these are the tables corresponding to the default entity framework core models that we have inside ASP.NET Core Identity. By default, all of these tables name will be prefixed with ASP.NET. Now let's check what are these tables stands for. So first of all, we have the table or entity user, which is having these properties or corresponding columns like username, email, password, phone number, etc. Then we have this role entity consisting of the collections of roles that we have inside our project, like admin, accountant, HR, etc. and etc. Then we have this user role, which is saying what are the roles assigned to a particular user. Now you can see this entity user claim and role claim. These are the additional informations that we can add to a user or a role. You will understand them better after the third section. And then we have this user token representing the token assigned to a particular user. This will be helpful when it comes to our token authentication. What is meant by token authentication will be discussed in next video. And finally, we have user logins. It represents or store information about user logins, especially when it comes to external logins like Google, Facebook, etc. So that's all about the DB part to get started with this project. Now back to the Program.cs file again. So these are the services that we have added from Identity Core, including the various endpoints to make use of the handlers inside the framework. In order to add the respective routes into this application, we have to configure this app object like this, app dot. We have to call this method map identity API. Here we have to specify the model class that we use for the entity user. So by default that will be identity user. Now let's run this app to see the various endpoints exposed from ASP.NET Core Identity. So these are the various web API methods or endpoints that we can make use of to implement the identity solution inside our project. Now the URL to this web API method will be like this, localhost, then this port number /register. Now since we are inside a .NET Core Web API, we have to prefix API just before this endpoint here. So API /register, API /login. In order to do that, we can do this just before mapping the identity endpoints. We can invoke this method map group, and inside that we can pass this /API. Let's build this project. See, that's it. Now in order to register a user, we have to consume this post web API method here, API /register, and it is expecting these data like email and password. Now if you only need these two information for creating a new user, you can make use of this post web API method. But in this tutorial, we also want to show you how to customize the identity as per your requirement. So in case of this user registration, along with these two informations, we also need the full name of the user. For that, Back to the project. Now we'll create a new model class. I will name it as app user. Now we have to inherit this class from the identity model identity user. So along with the properties that is there inside this model class, we have to add this extra property for full name. Now let's specify the data type corresponding to the SQL Server column. So here we have the attribute column. Into that we can pass this type name. Let it be nvoc 150. Now you could see this green squiggly line here saying a non-nullable property must contain a non-null value. In order to disable this warning, just place the cursor inside this property, then expand this drop down, suppress or configure issues, configure severity, click on silent. Now ASP.NET Identity recommends adding the data attribute personal data to all the properties which are related to personal information of the user. Now let's copy this user class from here and let's update the same wherever we have used identity user so far inside this project. You could see all of them inside this Program.cs file. First of all, we have the mapping for the identity endpoints, and then we have mentioned the same while adding the services for API endpoints. Okay, let me save this. Let's build this project. Build is successful. Now let's do the DB migration again for the newly created property here, full name. So open Package Manager console. First of all, execute this command add migration. I will name it as name is added in user entity. Hit enter. Finally, we have to execute this command update database. Sorry, we forgot the important step, which is adding a reference of this app user class into this DB context class here. Because when it comes to entity framework core, everything will get connected through this DB context class. So if a new model class is added to the project and which is not added here, and then it won't be considered in future DB migrations. So all we have to do is just define this property DB set for the model class app user. Now this property can be used for interacting with the corresponding table. So I will name this property as app users. Let's save this. Back to Package Manager. Let's re-execute the commands. I will name this migration as second try. Update the database. Back to the Management Studio. Refresh the DB. Let's expand the columns of this user table. So here is the new column full name. Now during the user registration process, along with these details, we also have to pass the full name. So instead of using this default web API method, we're gonna create a new post web API method for user registration. That we can do inside the Program.cs file itself. Later we can organize everything into respective files and folders. Instead of conventional controls like this, we're gonna use minimal API controllers inside this project. With this new minimal approach, it is really easy to create new web API methods and way more satisfying than conventional controls. So in order to create a post web API method, all we have to do is from this app object, we just need to call this method map post. So this becomes a post web API method. Now as a first argument, we will pass the URL. It will be API/sign up. And here we have the corresponding callback to handle this request. As per the current setup of Identity Core, there is no straightforward method to reuse this URL. And with the current version of the framework, we can't extend already existing implementation of the verb methods from Identity API. Could be made available in upcoming versions. So that's why we have created a separate URL here. Now talking about the actual implementation. Hope you know that ASP.NET Core Identity is an open source project. You could see the actual source code inside the GitHub repository here. And if you want to see the actual implementation or source code of these identity web methods inside this project, you can search for this file Identity API Endpoint Route Builder Extensions. Inside that, you could see the actual implementation of the Web API methods that is available inside the project by default. So for example, if you want to see the actual implementation of the Web API method, which is responsible for the registration of a user, here is the Web API method. And for login, you could see the post Web API method here. So like that, most of the Web API methods that is exposed from the identity solution by default could be seen inside this file. Back to the topic. Now let's handle this post request inside this callback. First of all, we have this parameter user manager. Along with this manager, we also have to pass the model class for the user entity. That will be the new class that we have created, app user. We'll name this parameter as user manager. Now we need a second parameter to accept the user information that is passed through the body of this request. For that, I'm going to define a class like this, user registration model, after executing or invoking this run method here. Don't worry, we'll organize everything in next lecture. So this class represents the properties that we expect through this post Web API method: email, password, and full name. Now let's add the second parameter accordingly. From the body of this request, we expect the properties that we have inside this class user registration model, and we'll name this parameter as user registration model. From where do we get an instance of this user manager class? Now we need this user manager to do any operation related to user. In this case, we have to create a new user. We have already seen this class user manager while explaining the structure of the identity solution. Identity manager layer consists of these manager classes. We have already added the respective services with this method add identity API endpoints along with adding the entity framework stores. So an instance of this user manager comes from the dependency injection that is done with these two method invocations here. Like we have seen with the DB context class, the dependency injection is done here, and from there, all the classes having a constructor parameter of this type will be assigned or shared with an instance from the dependency injection that we have configured here. Similarly, the dependency injection done for the manager classes will share an instance for this user manager parameter here. Now let's go ahead with user creation process. First of all, we have to create an instance of the model class app user. First of all, we have email, and we'll assign the corresponding value from the body that we have passed to this post Web API method. Now similarly, we have to assign the full name. Now in order to create an user, all we have to do is from this user manager, we can invoke this method create async. Inside that, we can pass the user object that we have created. Now as a second argument, we have to pass the password. That's why we have skipped passing the password into this app user object. Now let's pass the same from this registration model password property. Now since we have an async method here, we can prefix this method invocation with the keyword avoid. At the same time, you could see that this async keyword is automatically added here. Now we have to store the return object from invoking this method into this variable result. Now based on how this operation is carried out, we can return the response from this Web API method. For that, we can have this if clause. If this operation is successful, inside the result object will be having a boolean property succeeded. It will be set as true. In that case, we can return the response like this. Results.ok method can be called. Inside that, we can pass the result object. So this will return the response with a status code 2.1 indicating the user is successfully created at the Web API. Else, we'll return the response like this. Instead of OK method, we'll invoke this method bad request. Now this is all we need for creating a new user inside ASP.NET Core Identity. Now depending upon your future requirements, you can extend this Web API method. For example, if you want to verify the given email address from the user, you have to make the required changes inside this Web API method. Okay? Now let me build this and let's create a new user. Now inside this Swagger UI, you could see the new post Web API method that we have created, API/signup. Click on try it out. So first of all, we have the email address. For now, let's keep this password as it is, string. Then we have full name. Click on execute. You could see that we have got a response with the status code 400, meaning that a bad request is sent from our client side here. So here we have the response body having succeeded property is reset as false. To see the actual problem, you could inspect this errors array. So basically these are the errors or validation errors for the password that we have passed. So by default, the password must have at least one alphanumeric character, meaning that there should be at least one special character inside the password, then at least one digit, one uppercase. Now if you want to keep these validations as it is, you can do that. But if you want to customize these validations, you can do that also. So inside this Program.cs file, with this builder object, we could do this builder.services.configure method can be called. And here we want to configure the identity options. This collection of services can also be used to configure like we configure with the app object here. Along with adding services, it will also be used for configuring the added services. So here we go. We have this lambda expression with this options parameter. Options.password. Inside that you could see the various validations applied to this password property. So first of all, I want to disable this validation for required digit. Let's duplicate this. Let's disable the validation related to the uppercase and lowercase requirements. Now along with all of these, I want to enable a new validation. It goes like this, options.user. Inside that, I want to set this require unique email as true. By default it is false, so no user can have same email address. Okay, so with that being done, let's build this project again. Let's try to create a new user again. Now let's specify the password. Now by the way, these are the default validations applied to the password property. Required digit, which we have already disabled. Then we have the min length validation. At least there should be 6 characters. Both of these validations, lowercase and uppercase, are already disabled. And we have to keep this at least one special character requirement. And finally you could see this unique character validation, which at the moment is set as 1. So technically it is disabled. Now suppose if it is assigned with a value more than 1, say 2, then passing a password like this, repetition of same character is not allowed. There should be at least 2 distinct characters. So that's what this validation implies. When it is set as 1, technically it is disabled. So at present we have these 2 validations, minimum 6 characters, and there should be at least 1 special character. So here we go. String, then I will add this special character. In total we have 6 characters. That's enough. Now let's provide a full name. Click on execute. Now you can see another error here saying that username is invalid, can only contain letters or digits. Now as per the default identity model implementations, the username can't be blank. For this particular identity solution, we are not asking for the username. Nowadays, most of the application is not asking for username. Instead, they use email address. If you have such a requirement where username is required, you can pass that and do the required changes inside the web API method. Okay. Now, in order to disable this error, we often pass this same email address into the username property. Now, before making the changes inside the web API, first of all, let me copy this object to the clipboard. We'll need that for the next try. So here we go. Along with passing the email, we'll pass username with the given email address here. So that will solve the problem. Save this, build the project, back to the Swagger UI. Making changes inside the web API will reload the page, and that's why we copy the last user object. Click on try it out and let's paste the same here. Click on execute. Boom. So here we have successfully created the user inside the ASP.NET Core Identity. Let's verify the same inside this user table. See, here we have the new user with given credentials. You won't see the password that we have passed. Before saving it, it will be hashed into a format like this. Now let's head over to VS Code and let's make a post request inside the form submit event to consume the web API method that we have just created. Now, before making the actual post request, we have to implement all the validations that we have inside the web API endpoint to the Angular registration form also. Okay? I think we have to change the responsive classes that I have applied inside the parent component here. User component, instead of XXL, let's start applying this class from LG itself, and let's change this to MD8, and let's change the offset accordingly, MD-2. Okay, that's fine. Now back to the registration component. Let's implement the validation. For that, back to the component TypeScript file. First of all, we want to set this full name control as required. For that, we can pass the validations from the second element of the array here. So validators.required can be passed. The same required validation is to be applied for rest of the controls, so email and password. Now for email, we want to verify the correctness of the email format. For that, we can pass this validation validators.email. Now when we have multiple validations like this, we have to pass them as an array like this. Now for password, we have multiple validations. In order to pass them, we have this array here. Inside that, we already have the required validation. Now let's apply the min length validation. So validators.min length, there should be at least 6 characters inside the password. And finally, the password must have at least one special character, so we can implement the validation with regular expression like this. We just need to invoke this method pattern. Inside that, we can pass this regular expression. The character must be outside English alphabets, digits, and white space. Now apart from these given validations here, we have an interdependent validation to match this password to this confirm password value. So we have to apply the validation on this form group level. So as a second parameter to this method group, along with passing this object, we can pass an object like this. Inside that, we can make use of these validators. For the particular validation requirement, there is no built-in Angular validator. So we have to do it on our own. For that, we can pass a function to this validator property. Password match validator. Now let's define this method here. This method should be implementing the interface validator function from Angular. This interface is imported from Angular forms. Now here we have the function. The function is having a single parameter control, which is of the type abstract control. Now there is nothing to return from this function, so I will set the return type as null. Now here we have the function implementation. Now as you can see here we have an error saying that the method is used before its initialization. So let's move this function from here to here. Now at the end of this method, we have to return null. Now first of all, we have to retrieve the object corresponding to these form controls, password and confirm password. So here we go. For that, we can make use of the control parameter. From that, we can invoke this method get, and inside that we can pass the name of the property password. Let me copy paste this for confirm password. Now here we have the if clause. Inside that we have to verify that there is a value for these control objects. So here we go, password and confirm password, and then we can compare the containing values like this, password dot value. If it is not equal to confirm password value, we'll set the validation error. For this control, confirm password control, We will set the error using this method setErrors. All we have to do is we'll pass an object with this property password mismatch. We'll set it as true. Else we can clear the errors. For that, let me duplicate this and let's pass null here. Sorry, here we have a warning that this method invocation here is deprecated. It's because here we have a typo while passing the validators. So use small letter v. So this is how we can implement interdependent validations in Angular 4. You could see the detailed documentation of this validator interface inside the official documentation here. Just search for validator function and here we have the API reference. The function must have a parameter of the type abstract control. So that's what we have here. From that, using this method get, we can retrieve all of the objects corresponding to each of the controls that we have inside the form group. And using the control object, we can compare the values inside the controls and then we can set the error like this. Inside the documentation, you could see that the method must be returning an interface of the type validation errors. Now inside the description, you could see that this function receives a control and synchronously return a map of validation errors if any error is present. Otherwise, it should return null. Now inside our project, we have returned null instead of validation errors. If you return validation errors, the errors will be there inside the form group object here. Instead of that, we want to assign the error to this particular control confirm password. So that's why we have invoked this method setErrors, and from this method we always return null. So hope you understood how to make use of custom validation in Angular forms. Now let's show the validation error messages along with the respective controls. So back to the component.html file. First of all, we have full name, so we'll add this div having this clause error feedback. We only want to show this div if there is any error related to this required validation of this full name. So here we have the ngIf directive, ngIf. Inside that we can specify the condition. From this form group object, we can retrieve all of the controls using this property. Inside that we have this property corresponding to the full name control. Now using this method has error, we can check if there is any error related to the applied required validation. If there is such an error, we can show this error message, please enter your full name. Now this is a custom class to highlight the validation error feedback, which is not there inside the Bootstrap, so we have to add the corresponding CSS rule inside this global style sheet here. Now back to the form. Now along with this ngIf directive, you could see the error for not importing the common module. You can import the module inside this component level, inside this imports array here, like we have imported this reactive forms module. Common module. Back to the component.html file. Now you could see the validation error for the control full name here. Please enter your full name because at present this full name control is having the required validation error. If you populate the control becomes valid and there is no validation error. Now instead of showing this validation error in a fresh form like this, we have some criteria to be satisfied before showing this validation error here. To define the criteria, I'm going to define a function inside this TypeScript component here. So here is the function has displayable error. For this function, we only have a single parameter control name of the type string. And from this method, we will be returning a boolean value. Now let's define the criteria inside this method. Before that, I'm going to create a boolean property inside this component, which is submitted, which is of the type boolean. By default, its value will be false. So this property tells whether this form is already submitted or not. Now we have to set this property to true inside the form submit event here. Now back to the function. First of all, I'm going to create a property control. Inside that, we will save the object corresponding to the object for the given control name here. That we can retrieve from the form group object form. From that, we just need to invoke this method get. Into that, we can pass the control name. Now from this function, we are going to return a Boolean expression saying whether we want to show the validation error for this given control or not. First of all, this control must be invalid. That we can check using the control property invalid. As you can see here, this property can have a Boolean value or undefined. So we have to convert it into a Boolean value. So we will just wrap this property with the Boolean constructor. So this is the first criteria. So the control must be invalid. So that's the first criteria. Along with that, it should meet any of the following criteria. Either the form is submitted or the control is touched. This touched property will be set as true when user engage with this control here. So even placing the cursor inside the control will be treated as an engagement with the control. So this validation feedback will only be shown if this criteria is met. So here is the condition. If the control is invalid and either the form is submitted or the user is engaged with this control, then the validation feedback will be shown. So let's invoke this method has displayable error inside the component HTML here. We can do that inside this ngIf directive here. We'll invoke the method has displayable error. Inside that we can pass the control name. So that will be full name. Now inside this fresh form, the validation error feedback of an input control will not be shown unless the form is submitted or the user has engaged with the control. Now we have to do the same for rest of these controls. For email, we have two validation requirements. It should be required and it should have the correct email format. So here we go. Let me copy paste this div for email. Now let's check whether we have displayable error for the email control. Then only we'll show this div. Now since we have multiple validation, we can add extra child divs like this. So this div will only be shown if there is a required validation. So let me copy paste this ngIf directive. If the control is having the required validation error for this email control, we will show this div here. Inside that, we can have this feedback. Please enter your email address. We can remove this condition from the parent div. Now if the control value is having incorrect email format, we can show the error message in another div. So let me copy paste this div. This time we are looking for email pattern error. So inside that we'll be showing this, please enter a valid email address. Now for password, we have three validations. The control is required. There should be at least 6 characters and we have enforced at least one special character with this regular expression. So I'm going to copy paste this div of email for password. First of all, let's check whether we have an error related to the control password. Now first of all, if there is a required validation, we will show the error inside this div. Please enter your password. And if there is any error related to min length, at least 6 characters required. And finally for the pattern, I'm going to add one more div. For that we can check if there is any error related to the given pattern. So inside the div, we'll remind that there should be at least one special character. Let me save this and let's check how it works. We have already tested the full name. Email is required. So here we have the required error. Now if the user provides an invalid email format, you will get the pattern error. Enter a valid email address. Now for password, the control must be required and there must be at least 6 characters. Right now, as you can see, multiple validation errors are shown here. Most often when a control is having multiple validation error feedbacks, we prefer showing one validation at a time as a kind gesture towards the end user. So this is what I'm gonna do. Inside the app structure, I have shown you a pipe. First key pipe. Let's create that now. So here we go, ng, G for generate, P for pipe. You want to create that inside the folder shared pipes first key. Hit enter. So here we have the new pipe first key. Now the implementation of this pipe could be discussed in a bit. If this is the first time you are using Angular pipe, don't get frightened. We'll explain in brief how it works. Now let me show you how to make use of this pipe for implementing the validation requirement that we have. Back to the component.html file. As you know, each of these divs here represent the error feedback of each validation that we have applied to the password control. Now in order to display one validation at a time inside this password control, we'll make use of Angular switch directive. You could see the detailed documentation here, ng switch. Look for built-in directives, so here it is. So inside this parent div, I'm going to add an ng container for the switch. So here we go, ng container. Now here we have the switch directive, ng switch. Into that we have to pass the errors from the control password. So password.errors. This switch directive will work as exactly like the conditional statement switch from any language. Now let me move these child divs into this switch container. Instead of ngIf property, we want to use ng switch case. So this is corresponding to each of the case in a switch conditional statement. Now into this switch here we have passed an array of key value pairs. Instead of that, we want to pass the key name of the first error from the collection. The key name will be the name of the validation criteria, so it would be any of these: required, min length and pattern. For that, we can make use of the pipe that we have created here. So first of all, we have to import this key inside this component TypeScript file here. Back to the component.html. Now we can use the pipe here like this. Along with these errors, we'll use this operator, single or operator. Then we can pass the pipe, which is first key. You could see the detailed documentation inside this templates, then pipes. Actually, you could think of this Angular pipe like a real pipe. For this pipe, here we have the input. And what this pipe returns on the other end will be assigned to the switch directive here. Now what this pipe returns depends on its implementation. So basically the class for the pipe must implement the interface pipe transform. And this name that we have given here should be used inside the HTML file like we have done here. Now this transform function decides the output from this pipe. Now as I told you, what we have before this OR operator will be taken as the input for this type here. So these errors will be of the type validation errors. So basically it's a key value pair. So the same could be received with this parameter here value. Now in order to make use of this pipe globally for any key value pairs, I will change the type of this parameter to any. And we don't need this second parameter here. Now from this method, we'll either return a string or null. We'll be passing key value pair to this function, and from this method we'll return the first key pair key name. So first of all, here we have the property keys. Into that we'll assign the keys from this object. So we could do this object dot keys. So this will return an array of keys inside the object value. Now with this if clause, we will check there is at least one key. If that's the case, we'll return the first key. Otherwise it will return null. So the key that we are returning here is the name of the validation error, like required, min length, pattern, etc. So with this switch case, we are going to equate the value first key with required. We have to enclose the value inside single quotes. Now here we have min length. Now here we have to equate it with pattern. Now you see, first of all we have the required validation, then min length, and if it is met, then we have the special character error. Boom, that's it. So that's all about the password. Now finally we want to show the validation error for this confirm password. For that, I can copy paste the div of this full name validation error feedback, copy and paste the same here. So first of all, we will check whether this control is having a displayable error, and we will check if there is any error related to the validation that we have given here. Let me copy the key from here, password mismatch. So if the control is having this validation error, we will show this error, passwords doesn't match. Let's try the same. Now we have to pass the same into this confirm password. Otherwise, we will return error like this. See? So here we have done with the client-side validation for this registration form. Hope you have learned all about validating controls in Angular. Now let's go ahead with submitting this registration form and passing the form data to the web API method that we have just created, this one. So back to the component TypeScript file. Here we have the form submit event. First of all, we will check whether the form as a whole is valid or not. For that, we can make use of the form group. From that, we can check this property valid. Then only we'll post the data to the web API method. Now, like I have already mentioned, in order to make the HTTP request to the web API method, we'll make use of this auth service. So here is the service, auth service. Now, in order to make an HTTP request, first of all, we have to inject HTTP client class. To do the injection of the HTTP client, first of all, we have to go to this app.config.ts file. Then inside this providers array, we have to invoke this method provide HTTP client. Now back to the auth service. Now we can receive the instance of the HTTP client like this. Inside the constructor, we'll create this parameter HTTP of the type HTTP client that we have just injected. Now let me create a property to save the base URL of the web API. So here we go, base URL. Let me copy the URL from here. Along with this, we have to append API. Now I'm going to make a post request to this web API method here, API/signup. For that, I'm going to create a method here, create user, having a single parameter form data of the type any. So this will be the form data object submitted from this user registration form. Inside that, to make a post request, all we have to do is from the injected HTTP instance, we can invoke this method post. So this will make a post request. As a first parameter, we have to pass the URL. So along with this base URL, we'll append /signup. As a second parameter, we have to pass the form data. Now this method will return an observable as you can see here. Now from this service method, we'll return the same observable like this. Now we can inject this auth service inside the component TypeScript file. By default, all of the Angular service classes can be injected anywhere inside the application because of setting this property provided in as root. So back to the component. Inside the component constructor, we can receive an instance of the service class like this. Private service, which is of the type auth service. Now from the form submit event, we can invoke the method that we have just created inside the service class. So here we go, service.createUser. Into that we have passed the form data. Now as you know, this will return an observable, so we can make the subscription here, subscribe. To pass the error and success callback, we can pass an object like this. We can handle the success callback inside this next callback here. Now here we have the success callback. If anything went wrong, we can handle that inside this error callback here. Here we'll just print the error object like this. Inside this success callback, we'll just print the response. Now the web API is already running here. So let's make the post request from this Angular client. First of all, fill in the form with valid data. Submit the form. Let's open the console tab. See, here we have an error saying that this HTTP request for the web API from this Angular app has been blocked by Core's policy. Actually, this is much expected. As you can see from this error, it's because of the Core's policy. CORS stands for Cross-Origin Resource Sharing. By default, any web API framework will block a request from a different domain or different port number. In this case, we have different port numbers. So first of all, inside the web API, we have to configure the CORS policy in order to accept a request from this Angular app. So back to the web API project. Then inside this Program.cs file, we could enable the CORS policy for the particular Angular app. So all we have to do is just invoke this method use CORS from the app object. And it must be invoked just before invoking the use authorization method like we have done here. Into the method, we can pass a lambda expression like this, specifying the configuration that we have for the CORS policy. From this options parameter, we can invoke this method with origins. Into this method, we have to pass the URL of the Angular app. So let me copy this and pasting the same here. Make sure to avoid this / at the end. Okay. Now we have to allow all of the web API methods like get and post. For that, we can invoke this method allow any method, and we also have to invoke this method allow any header configuration for the request. Inside this web API, all we have is everything related to ASP.NET Core Identity. So I'm going to enclose this configuration of the course inside a region like this. Config course. Okay, that's it. Let's save this and build the project. Now we should be able to make the post request without any error. Now before trying submitting the form again, let's advance further inside the success callback of the HTTP post request. Now if everything goes well, the succeeded property inside the response will be set as true, which we have already seen while testing the web API method. So here we have the if clause. If the property is set as true, succeeded. In order to read this property from this response parameter, we have to set the response type as any. So if the user registration is successful, first of all, we want to reset this form here. For that, from the form group, we can invoke this method reset. And then we also have to reset this property is submitted, because the property is an indication saying whether this form is a fresh form or not. Since we have reset the form, it's a fresh form. So we have to reset the property is submitted as false. Now in addition to this, I want to show a notification saying the user registration is successful. For that, we're going to install this npm package ngx toaster. Let's copy this installation command. Let's open the terminal. Paste the command, hit enter. So here we have successfully installed the package. Now how do we want to configure the package is mentioned inside this npm page here. We have already installed this package. Now we also have to install this package Angular / animations, which is already there by default inside the Angular app. You could check that inside this package.json file. Then after that, we have to add the CSS file into our Angular app. That should be done inside the angular.json file. So let's copy this style sheet reference. Then open angular.json file. You see here we have to add the style sheet reference into the styles array. So what I'm going to do is I will search for the array styles. Now let's paste the path of the style sheet here. Now actually there will be two arrays with the same name styles, one for production, one for the actual build. So we could find that through this find utility itself. So here it is. Let me paste it here also. Then next we have to add the toaster module, or we have to inject the toaster provider. Since we are dealing with standalone components inside the app, we could invoke this method provide toaster inside this file here, app.config.ts file, exactly where we injected the HTTP client. So here we go, provide toaster. Now the toaster service is available inside our Angular app components. So back to registration component. Inside the constructor, we can receive the toaster service like this, private toaster, which is of the type toaster service. Now wherever we want to show the toaster notification, we can make use of this toaster service. Now if the user registration is successful, I want to show a success notification. So I will do this. Toaster.success method can be called. As a first parameter, we can pass the notification message. As a second parameter, we can pass a title. So here we go, registration successful. If anything goes wrong, we will print the response like this. Now let's try submitting the form again. Before that, it's better to restart the Angular app because for configuring this toaster service, we have made changes outside the src folder, which is inside this angular.json file. So it's better to restart the server. So open the terminal where we are running this Angular app. To stop the server, use this shortcut Ctrl+C. Let's clear the previous entries. To start the server again, we can re-execute this command ngserve-o. Let's try to submit the form with random data. Submit the form. No notification is shown. Let's open the developer console. Actually, I think the record is inserted and currently this error is from the toaster service. You could verify that inside the DB. Let's rerun this select statement. See, here we have the newly added user. So this error is from the npm package toaster. Later, I found that it was my mistake. Along with adding the toaster service, we also have to add the providers for animations by invoking this method provide animations. So let me copy this, then back to the app, open app.config.ts file, and let's invoke the method here provide animations. You know what? Instead of this version, I will go for the async version here. Okay, let me save this. Back to the app, reload the page again. Let's try with another user. Submit the form. Boom. See, here we have the toaster notification. Let's re-execute the select star statement. So here we have 3 users. Make sure all of the data are properly entered into the table. Sorry, I was trying with random data. So it would be difficult to verify whether we have saved the same data that we have passed from our client side. So what I'm going to do is, I'm going to delete everything inside this table like this. Delete from user table. And let's create a new user. You know what? Before trying that, let me change the position of the toaster notification. By default, it will be shown inside the top right corner. Instead of that, we want to show them here, top center. We can configure that while adding the provider itself. You could see the detailed documentation here. So this is what I'm going to do. While invoking this method provide toaster, we can pass an object with this property position class. Inside that, we can pass this particular class toast top center. You could see these classes mentioned inside this configuration here. See, position class. So save this. Back to the app. So here we have the user Eva Elliott. This time we are trying with proper details. Email will be email@gmail.com. Password, string, then hash. Submit the form. Boom. Let's verify the same inside the DB. See, here we have the new user for Eva Elliott. You could see the same email address that we have passed here. Now finally, we have to do one more thing. There are some validations that can only be done at the server side, like duplicate email address. To show you the same, I'm gonna submit this form again with the same email address that we have used for previous user. So first of all, let me open the developer console. So here we go, email@gmail.com. Submit the form. See, we have got a 400 bad request and here is the details. If you expand the arrays, you could see the error details, duplicate username and duplicate email address. This is the proper one, duplicate email. Since we have saved the same email address into the username, we have the same error from that field also. So in order to consider the server-side validations, let's modify this form submit event here. Inside this else block, we'll be having a for each loop like this. Response.errors contains all of the errors that is returned from the server side. Now let's loop through them using this for each method. Inside that we have this callback with a single parameter x, which is of the type any. Now with this switch case, we can check each of the errors that is returned from the server side. Now in the previous duplicate error we have seen there was a property inside the error like code. So that's what we are going to match within each case here. So if the error code is duplicate email, we will show a toaster notification. So here we go, toaster.error method can be called so that a red notification will be shown. And here we have the message, email is already taken. And here is the title, registration failed. Finally, we have to add this break statement. Now whenever this happens, we'll also get the error for duplicate username because we are saving the same email address to the username field also. So in order to avoid that, we could do this. If the error code is duplicate username, we will just break from the current iteration. So like this, you can customize the notification for server-side errors. Now if the error code is none of these, we can have this default case here. Let me copy paste this error method invocation. The error message will be something like this, or contact the developer. Now along with that, we'll print the error object to the developer console. So just print the X object. Finally, here we have the break statement. Let me save this. Back to the app. Let's try the same again. email@gmail.com. Submit the form. It didn't work as expected because the errors object is having a parent property error which we haven't mentioned inside the code, and there is one more thing. We have to do this switch comparison inside this error callback here, because if the user creation fails from the web API endpoint, we are returning a bad request containing the error details. So that will end up in an error response, so that will be caught inside this error callback here. So first of all, the errors object is the inside this parent property error. So let's correct that here. Now let's move this for each into the error callback. Now we have to look for this error inside this error parameter. Now actually we don't need this else clause inside this success response. Now inside this error callback, we'll only loop through this array if this object is present. So first of all, I will check if it is present or not. Otherwise, we want to handle this error inside this else block here. We'll just print the error object like this. Let's save this and back to the app, and let's do the same again. Submit the form. Boom, that's it. Email is already taken. Finally, before winding up this tutorial, I would like to give you a bonus tip regarding validation. If you enter invalid email address into this control, the validation error will only be shown if you disengage with the control, because at present the criteria for displaying the validation error feedback is determined with this function here, has displayable error. So the control must be invalid and either the form must be submitted or the control is touched. Currently, this error feedback is shown because the value of this touch property is set as true. And that will only happen when we disengage with the control. For example, if you pass an invalid password, the error feedback will only be shown if you disengage with the control. See, if you want to show the validation error even before disengaging with the control, you can do this. Along with checking whether the control is touched or not, we could check whether this property dirty is set as true or not. So this property dirty will be set as true when we change the default value of the control. If the control is having the default value, then this property pristine will be set as true. So these two properties are quite opposite. Now for an invalid control, even before the user disengaging with the control, if the user change the value of the control, we will show the validation error. See? So that's all about user registration. Now in this section we'll discuss all about implementing JSON Web Token user authentication, login and logout using the ASP.NET Core Identity framework. Starting from designing the beautiful login form and then discussing everything you need to know about JSON Web Token, how to implement user authentication with ASP.NET Core Identity, implementing logout feature. So first of all, we will start with designing the Angular login form and then we can go ahead with implementing the user authentication inside the Web API. So without further ado, let's get started. In previous section, we have created the user registration form using this component registration, which is the inside this parent component user. Inside that, we also need to create this child component login. Inside that, we can design the login form. Now, through this login form, when a user is successfully authenticated to the system, we have to redirect the user to the dashboard. For that, we also have to create a component called dashboard. So let's open the terminal. Inside this terminal, we are already running the Angular app. So let me open one more terminal and let's create these components here. First of all, we have login. So here we go, ng, g for generate, c for component. Let's create the component login inside the folder user. So here we have the new component login. And along with that, we have to create one more component for dashboard. So here it is. Now at present we are directly showing the user component inside the default app component. Now instead of that, from now onwards we have to use Angular routing because we have multiple pages to show. Previously we only had the registration form. So we have to make use of the tag router outlet. To make use of this tag, first of all, make sure that the corresponding component is already imported this router outlet here. Now let's go ahead with setting the required routes for this application that we can do inside this TypeScript file app.routes. So first of all, let's add a route for the user registration. For that we can have this object. Inside that, first of all, we'll provide the path as user. With this path, we want to show the component user component, which is the parent component. Now inside the app, if you use this URL /user, the registration component is getting rendered inside the parent user component. Because at present inside the user component, we are directly showing the component for user registration, as you can see here. Instead of that, I will provide a router outlet here also. To make use of this router outlet inside this template, first of all, we have to import the same inside the TypeScript component here. Router outlet. See, at present with this route here for /user, only this user component HTML is shown here, which is the wrapper div that we have provided for the user registration component. So with this route for /user, the first user component is replaced in place of this router outlet. Now, in order to replace the second router outlet inside the parent user component, we should be providing routes corresponding to the children components. For that, inside this parent user component route object, we can add an array children having routes corresponding to the components login and registration. So here we go, path is equal to sign up, and we'll be showing the component registration. Now, along with this path, if you append this sign up, we will show this registration component inside this wrapper div here. See, it's because the first component is replaced inside the first router outlet. And the second router outlet inside this user component is replaced with the component that we have inside this children array. Similarly, with a login route, we have to show the login component inside the same wrapper div. So here is the path login, and we want to show this component login component. So if you try this URL, user/login, see inside the wrapper div we have the default text from the login form component, as you can see here. Now finally, I want to make one more modification inside the routing configuration. It would be better to remove this parent component path user. From now onwards, in order to render the child components, we only need to pass the child path, and the respective child component will be rendered inside the parent component like before. So in order to render the user registration form, we just need to provide sign up, and that of the login form will be like this. Okay, now let's go ahead with designing the login form inside the component here. So first of all, let's import the required modules, common module and reactive forms module. Now let's inject the form builder like we have done inside the registration component here. We have injected the form builder inside the constructor, and with that we have created an instance of form group. So let's do the same inside this login component. Here we have the constructor. Let's inject the form builder. Remember, like we have done in previous section, instead of injecting this form builder at constructor level, do the manual injection like this through creating a field and using the method inject. Okay? Now we can create an object of form group with this form builder like this. Just invoke this method group. Inside that we can pass an object having different properties corresponding to different form controls that we need inside the form. First of all, we have email. Let me copy paste that from this registration form group. Let's import this validators. For this control, we'll only set this required validation. So we don't need this array here. Now we need one more control for password. So these are the two properties corresponding to the login form text boxes, email and password. Now let's open the corresponding component HTML file. First of all, we need a form element. We don't need this action attribute. Instead, we will set this property form group. Here we can provide the name of the form group object that we have created. Now let me copy paste the control from the registration form. Let's copy paste this div corresponding to the full name. Placeholder will be email. Form control name email. Now let me comment this div corresponding to the validation error feedback. Let's copy paste this div for password. Placeholder will be password, and here is the form control name. Finally, we need this submit button. Let me copy paste that from here. Inside the button, we will show this sign in. Now let's show a heading like we have done inside the sign up form. You could see the corresponding div here, this one. A small typo. This text should be shown inside an h2 element having this text class here. So here it is, h2 element having the class text success. Inside that we can show this sign up. Now let's remove these two from here. That's it. Now let me copy paste the same inside this login form component. So here is the title, sign in. Now let's see how it looks like inside the login component. Instead of navigating the component through URL, let's provide back and forth navigation inside the sign up and login form component. So first of all, inside the registration component, just below the heading sign up, we can have this div. If you already have an account, you may want to navigate the login form. So here is the hyperlink having bootstrap classes, text, decoration, none. So this bootstrap class will disable all of the default styles added to the hyperlink. Let's set the font weight to medium and let's set the font color to green. In order to show both of this caption and this hyperlink in a single line, we can have this bootstrap class d-inline block. Inside the hyperlink, we will show this sign in. Now, in order to set the destination URL, we can make use of this Angular attribute router link that will be /login. In order to make use of this property router link, first of all we have to import the same inside the TypeScript component here. Router link. Now you know what, instead of this path login, let's use sign in. So let's change that inside this app.routes. Sign in. Let's change that here also, sign in. Now if you click on this sign in, you will be directed to the login form. Now inside this login form, we need a navigation back to the user registration form. For that, let me copy this div and pasting the same inside the login component just below the header like this. So here we have the caption, don't have an account. If that's the case, you can go to this route here, sign up. And don't forget to import the router link inside the TypeScript component. See? Now later, in this back and forth navigation, we'll be adding a fade in effect with Angular animations. We'll do that later, okay? Now let's deal with the validation inside the form. The validation is pretty simple. Both the controls, email and password is already set as required fields. Now let's go ahead with displaying the validation error feedbacks along with the respective controls. For that, back to the login form component and let's uncomment this copy pasted div from registration form. First of all, here we have the function has displayable error, deciding whether we want to show the validation error for the given control or not. So first of all, let's copy the function from the registration component here. Has displayable error. It would be better to define this function somewhere globally accessible for all the components. For the time being, for both control, I will define the function separately. So to this function, we'll be passing the name of the control, and here we have written a boolean expression deciding whether we want to show the validation error feedback or not. So as you know, the control must be invalid, and either the form is submitted or the user is engaged with the control or the user changed the default value inside the control. This property is to be defined inside this control, which is indicating whether the form as a whole is submitted or not. So let's define this property is submitted, which is of the type boolean. Initially its value will be false, and during the form submission this property will be set to true. We have already discussed them in great detail in previous video. So to this function, for the first component email, we'll pass the name of the control as email. First of all, we'll check whether we want to show the validation error for this control or not. And here we are checking whether we have a required validation error for the control email. If that's the case, we'll show this error feedback. Please enter your email address. Now at present, for both of these control, email and password, we only have a required validation. So this is enough. Let me copy paste this for password. We'll invoke this function with this parameter password, and let's pass the same here also. If there is a required validation for password, we will show this. Please enter your password. See, the validation is working perfectly fine. Now to this form, let's wire up a function for the submit event. So here we go, ng submit. We will handle the event inside this method on submit. Let's define the function inside the TypeScript component on submit. First of all, we'll set this boolean value to true. For now, let's print the form data into the developer console. For that, we can make use of the form group object. From that, we can access this property value. Let's open the developer console. Let's try with a random data. Submit the form. That's it. All of the data that we have given inside these controls are properly getting posted. Now before going forward with implementing user authentication in ASP.NET Core Web API, let me make few more modifications inside the wrapper div. First of all, whichever form we have inside the wrapper div, we should place it in vertical center. And as part of this wrapper div, let me add a logo of this application. So back to the parent component user. To show the app logo, I will make this div as a raw div for the bootstrap grid. So here we have the class row. Inside that we need two columns with respective column clauses. Call md5 multiply by 2. Inside the first column we will show the app logo, and inside the second column we will render the component, either it is user registration form or the login form, which we already have here. So let me cut and paste these bootstrap classes to this column clause here. Now let's move this div into it. Now inside this first div, let's show the app logo. So let me add this image application logo into our app directory, public directory, like this. So here we have the img element having these bootstrap clauses. We'll set the width to 50% and let's add a bottom margin of the range 3. We don't need this alt attribute. Now into this src attribute we can pass the name of this image. For that you could do this, just drag this image into this editor and just hold shift and then place it here inside the src attribute. We only need to pass the name of the image since we have placed them inside this public folder. And then just below the image we can have this h2 element having this bootstrap clause font weight bolder. Inside that we can provide the name of the app, which is Auth.ec. Now for these two elements I'm going to add a wrapper div having these bootstrap clauses text sender, and let's set the text color to white. Let's move these two elements into it. Now this div will only be shown in screens having larger width. Otherwise we will hide it with this clause display none. Now let's set the background color to success. Let's apply the border color on left hand side of the range 4. Now along with this MD clause we want to set the display to flex. So here we go, display in MD width, set it as flex. Now in order to always align the content in sender we can apply these clauses align item sender. Along with that we have to set this clause justify content sender. So here we have the div that we have just added. Sorry, there is something wrong with the corner radius. Sorry, here we have a typo. That's it. Now as part of being responsive, we have hidden this logo in smaller devices. At that time, we want to show the second column in full width. For that, we can add this clause called 12 so that this div will take the entire width in smaller screens. Now adding this extra logo div here added more width to the wrapper div. So we have to change these responsive clauses accordingly. Instead of MD, let's set it as LG, and this LG should be replaced with XXL. In large screens, we will take 6 columns and offset of 3. So here we have the final result. Now as I said already, in this back and forth navigation, we'll be adding a fade in effect with Angular animation that we can do later. Now let's go ahead with implementing the user authentication with JSON Web Token inside the ASP.NET Core Web API. First of all, we'll start with discussing all the things that you want to know as a prerequisite to user authentication. And then we'll implement the user authentication in ASP.NET Core Identity using JSON Web Token. In previous section, we have given a detailed introduction to ASP.NET Core Identity and we have implemented user registration. From now onwards, the discussion on the framework ASP.NET Core Identity could be split into 3 parts. So first of all, we have client. It could be any API Explorer like we used previously, Swagger UI, or it could be Postman, or it can also be client-side applications developed in Angular or React. So whatever that is capable of making an API request into the Web API project. And then we have the Web API itself developed in ASP.NET Core. And finally, we have the database. In this project, we are using SQL Server DB. Now for better clarity, I will split the Web API into 2 parts. So first of all, resources, you could think of them as various web methods inside the Web API. And then we have the framework ASP.NET Core Identity. Now in previous video, we have discussed user registration, in which we have created a new user or new identity into the identity solution that we have. So from the client side, we have made a post request into this URL. Along with the user details, we also pass user credentials like email and password. and the respective web API method handles the request by saving the pass user details along with the credentials into the SQL Server DB with the help of ASP.NET Core Identity Manager User Manager. Now, as a next step, we are going for user authentication. So let's start with the definition itself. Authentication is the process of determining a user's identity. So during the authentication process, the web API expects the credentials which is first passed to the web API during the user registration process. Now it is the responsibility of the web API to check whether there is an identity with the given credentials. So that's what we are going to implement as part of user authentication in this video. So the process authentication involves authenticating a user and responding when an unauthenticated user tried to access a restricted resource. So as a first step towards implementing it, first of all we have to add the respective service into this iService collection here. It can be done simply with invoking this method add authentication from the service collection. So here we go, builder.services.add authentication will add the respective services for authentication. Now into this method add authentication, we want to pass the argument saying how we want to authenticate the user, whether we want to use JSON Web Token or any other authentication standards. Before that, I want to discuss the involvement of the framework middlewares in this process of identity solution. Now, when it comes to an ASP.NET Core web application, whether it is an MVC or web API, both the incoming request and the outgoing response must go through some established middlewares inside the project. In this given illustration, you could think of these vertical blocks as different middlewares. Now, if you are not familiar with ASP.NET Core middlewares, you could go through this in-depth article. I have given the link in video description. So basically, there will be a chain of middlewares in between the actual request and the destination of the request, and there will be similar middlewares while returning the response. You could think of these middlewares as a common necessary interruptions for the proper working of the app, and each one of them works one after other in sequential order. So the order does matter. Now inside this table, you could see the available built-in middlewares in ASP.NET Core framework. Some of the middlewares will be added by default into the project, and rest of them could be added as per your requirement, like these authentication and authorization in this project. Both of them should be added into this project with the respective method. Now just now we have added the required services for authentication purpose, and through this method we will say how we want to configure the authentication. But it won't add the necessary middleware into this application. For that, we have to invoke the use method use authentication. That will add the necessary middlewares for the authentication purpose. And that also must be done in the proper order. Among the middlewares that precede the authentication middleware, the course middleware is the closest one in sequential order, which we have already done in previous section as part of user registration. And then we have to add the middlewares for authentication and then authorization. So this order must be followed. So that's what I have shown as an example inside this illustration. This order must be followed. And most importantly, all of these middlewares must be added before adding the web API methods inside this project. We have to do the authentication or authorization before accessing the protected resource. Then only we can protect the resources from unauthenticated user. So first of all, here we have the course middleware from the previous section. And then here we have the method invoked by default inside this project, use authorization. It will add the necessary middlewares for the authorization, which we have not discussed yet. We'll do that in an upcoming video. We have added these two middlewares, course and authorization. In between, we have to add the middleware for authentication. For that, all we have to do is just invoke this method use authentication. So with this method add authentication, we will add the necessary services to the app and configure how we want to authenticate the user. And such a logic will be executed with the adding of this middleware here. In between these middlewares, course and authorization. So hope you understood. Now with this method add authentication, we want to specify how we want to authenticate the user. Now, before getting into the implementation, I think it would be more helpful if we organize the terms that we already heard of related to authentication or authorization. I mean, the standards or protocols that we most often use for authentication and authorization. At the same time, we are not getting into any details of these standards here. In this tutorial, we are only discussing JSON Web Token. I just want to make you aware of the alternatives that is related to this topic. In that way, you will not get frightened when you hear these fancy terms while you research the topic further. So first of all, we have OAuth 2. So that is a standard which is then extended into this OpenID Connect, in short OIDC, and then we have JSON Web Token. So these are the most commonly used or most well-known standards for authentication and authorization. Apart from them, you could see Security Assertion Markup Language, SAML, System for Cross-Domain Identity Management, and then we have finally Web Service Federation. If you want to know more about these standards, I have given the link to this article in video description. You can go through them and could study more about these standards. In this particular tutorial, we are using this standard JSON Web Token, in short pronounced as JWT. Now regarding this topic of authentication and authorization, you could see various categorization like based on different aspects of the process like password authentication, then biometric authentication, etc. and etc. All of the categorizations are done based on different aspects in the process. Okay. Now, before discussing JWT or JWT authentication in detail, we should be familiar with one more type of categorizing authentication methods. They are session-based or cookie-based authentication versus token-based authentication. These two types of authentication are more common when it comes to implementing authentication, particularly in web applications. While going through the documentation itself, you could see the terms like token-based authentication or cookie. So learning how these two types of authentication works and how they differ will give you a clarity on this topic of authentication. So first of all, we have session-based or cookie-based authentication. Now in this whole illustration, this part here represents the client browser. And here we have the server side consisting of the web API or the MVC application along with the database. And in between, you could see the request and response in between these two parties. So first of all, here we have the post request trying to log in into the web application here. And inside the server, the given credentials are verified. And if there is a user with given credentials, a new session record will be saved into the database, proving that this particular user is successfully authenticated into the system. As a response to this request, the session ID which we have saved into the DB will be returned. And then inside the browser or client side, the received session ID will be saved to the browser cookie. Inside your browser, if you open the developer tools, you could see application. Inside that, you could see the cookies related to each website. So for this application, this much cookies are saved. Similarly, the session ID will be saved to the browser cookie, and from there onwards, in order to access any protected resource from the web application, we have to pass the session ID as the cookie inside the request. And then inside the server side, before the request reaching its destination, the in-between authentication middleware will verify whether this session ID is present among active sessions. So while considering active sessions, the expired sessions will be ignored. And if this verification is successful, the request will reach up to its destination and then the proper response will be sent back to the client side. So that's how session-based or cookie-based authentication works. Now when it comes to token-based authentication, it is stateless, meaning that there is no involvement of database like we've seen in cookie-based authentication. There is no record saved in database proving that a particular user is successfully authenticated to the system. Now JSON Web Token Authentication or JWT authentication comes under token-based authentication. So here it goes. First of all, the user makes a post request trying to log in into the web application. And then of course inside the server side, the given credentials must be verified with already stored users inside the solution. And if this verification is successful, then a token will be generated. In case of JWT authentication, the token is called as JSON Web Token, in short JWT. The same token will be returned as a response to the request, and then inside the client side or browser, the JWT will be saved somewhere persistently. That would be outside the browser cookie. Most often that would be the local storage inside the browser. You could see that inside this developer tools itself, local storage and all the local storage key value pairs for this website could be seen here. So a key value pair like this will be used for saving the received token as part of a successful authentication here. And from there onwards, in order to access any protected resource from the server side, we have to pass the JWT inside the authorization header of the request, in which along with passing the JWT, we have to pass the prefix bearer. Don't worry about this, we'll be showing you how to send this JWT inside the request authorization header. This part of validating token signature is really important because inside this token-based authentication, there is no involvement of database to check whether this user has already authenticated to the system or not. We could discuss that in a bit. So if the token signature is validated successfully, then the request will get the access to the protected resource, and then the respective response will be sent back to the client side or browser. So that's how cookie-based authentication and token-based authentication differs. Inside the cookie-based authentication, a record is saved to the database proving that this particular user is successfully authenticated to the system. When it comes to token-based authentication, there is no involvement of database for storing the record proving that a particular user is successfully authenticated to the system. So that's one of the important difference between these two types of authentication. Along with them, you could see the difference in how the session or token is saved inside the browser, and from there on how it is passed to the server for accessing protected resource. Now let's dive deep into JWT authentication and let's see how it is able to do everything without saving any state of the authenticated user in a database. For that, here we have the official documentation of JSON Web Tokens. So first of all, we'll discuss how the JSON Web Token is generated. And then we can discuss how it is getting validated in the subsequent request. So basically, JSON Web Token has three parts: header, payload and signature. And each of these are separated with a dot or period symbol in between them. So typically the header part consists of two properties or two informations. First of all, we have sign-in algorithm and then the type of the token. Since we are dealing with JSON Web Token, we will set it as JWT. And with this property ALG, which stands for algorithm, into that we have to pass the algorithm that we use for encrypting this signature here. I will explain that in a bit. So most often these two algorithms are used, SHA-256 or RSA algorithm. In a bit we'll be explaining how this algorithm plays a role in generating the JSON Web Token. So the first part of the token will be base64 URL encoded version of this JSON object here. The intention or meaning of the URL encoding will be discussed later. And then comes the payload. So basically payload consists of claims. Claims are statements about the entity that would be the authenticated user and then some additional data about the token that we are generating. For example, inside this payload, you could see that the admin property is set as true, meaning that this logged user is an admin, and then here we have the corresponding user ID from the database, and here we have the full name of the logged in user. Along with these user related claims, you could see claims like this IAT. Those are the statements or additional information about the token that we are generating. You could see such predefined claims inside this documentation here. If you want to know what this means, we can search for IAT. See, it represents the time of issuing the token. So such informations or statements will be there inside the payload. Now before adding the payload into this JSON Web Token, the same will be converted into base64 URL encoded version. In between both of this header and payload, there will be a period separating them. And finally here we have the important part of this JSON Web Token, signature. Inside this signature, we are not hiding any extra information than what we have inside this header or payload. So this signature is generated using the algorithm that we have passed inside the header here. See, the same algorithm is used here for generating this signature, SHA-256. So this encryption algorithm will take this part here from the beginning of the token up to this second dot here will be taken as the input for the encryption, and then the same will be encrypted with a secret key that we have passed to it. Now, as you know, the JSON Web Token is generated as a result of successful authentication of a user. So this secret key must be private and should not be exposed to anyone outside the server. As long as the secret key is not available, no outsider can modify or break into this generated JSON Web Token. More about that could be discussed once we generate the JSON Web Token. So back to the project. At present, we only added the services for authentication here, and the corresponding middleware is added here with the app object. So before generating the JSON Web Token, we have to configure the authentication with the authentication standard we are using. So that would be JSON Web Token. For that, we have to install the NuGet package to work with JSON Web Token. So right click on packages, then manage NuGet packages. Inside this browse tab, search for this NuGet package, which I have given in the video description. You can copy paste from the Authentication JWT bearer. Let's install the package. So the installation is successful. Now back to the Program.cs file. Now to this add authentication method, we'll be passing a lambda expression like this. Now inside this lambda expression, we are going to pass authentication options. So these are the available authentication options that we can pass to the lambda expression. So here we go, x dot default authentication scheme, and then we have default challenge scheme, and then we have the default scheme itself. All of these three schemes will be assigned with JWT. So here we go, JWT bearer defaults dot authentication scheme. Now it's necessary to know what is a scheme. It's a combination of authentication handlers and their configuration. So you could think of these authentication handlers as methods defining how to handle a requirement in the process of authentication, and along with its configuration options together is called as schemes. So back to the authentication options here. Along with the schemes that we are passing here, you could see other schemes inside this table that the ASP.NET Core Identity is asking for. So this default authenticate scheme expects a scheme containing the basic core handlers related to the authentication process. And then this default challenge scheme expects a scheme containing handlers defining how to handle an unauthenticated request. And apart from these two schemes, authenticate scheme and challenge scheme, you could see other schemes inside these authenticate options. So for such schemes, we have not specifically set the scheme. So by setting this default scheme, all of such other schemes will be assigned with the scheme that we are passing here. So all of these schemes and rest of them is assigned with the JWT authentication scheme. So everything will be handled by JWT authentication scheme itself. In certain applications, there could be multiple authentication standards used. In those situations, these schemes could have different values or different schemes assigned to them. Now, we need to register the JWT scheme with necessary configurations. For that, we have to invoke this method, add JWT bearer method. Now, inside this method, we have to configure or tune the JWT authentication as per our requirements. For that, here we have the second lambda expression. First of all, we will say whether we want to save the token or not. Since we are going for JSON Web Token authentication, we will set it as false. Now we are going to specify how we want to validate the token for subsequent requests after a successful authentication. As I said already, how it works will be discussed once we generate the JSON Web Token. For now, let's configure how we want to validate the token. For that, we can assign this property token validation parameters. Now, in order to validate the token signature, we have to set this property as true. And to do the same, we need the secret key of the encryption. This secret key, we need this for validating the JSON Web Token. So here we go, issuer sign-in key is equal to, this option only accepts an instance of this class symmetric security key. Inside that we want to pass the encoded version of the security key. Now we'll save the security key inside this app settings.json file. So here we go, app settings. Inside that we'll have this secret key JWT secret. Now this secret key must be having at least 32 characters. For this demo project we have set the requirement of the secret key itself as the secret for the JWT authentication. So make sure to provide the secret key having 32 characters. Now let's pass the value of this key to this method getBytes. So here we go, builder.configuration. Now let's provide the path of the key. So inside app settings we have JWT secret. Now you could see a green squiggly line here saying there is a possibility of null inside this key. We already provided a value for this key, so at the end of passing this key you can add this exclamation mark like this. So in this way we can turn off the possible null error warnings when you can always ensure a value in the context. So first of all we have reset this boolean property saying that we don't want to save the JSON web token after its creation. And with this property we have specified how we want to validate the JSON web token in the subsequent request after a successful authentication. We want to validate the signature of the token, and here we have provided the necessary key or secret key for the validation purpose. We will be discussing how the signature is getting validated once we generate the token. Now it's time to create a web API method for login or sign-in operation. So we'll be making a post web API method with this URL. Inside the body of the request we'll be passing the email address and the password of the user. And inside the web API method that we are about to create, we will check whether there is a user with the given credentials inside the DB with the help of ASP.NET Core Identity User Manager. And if it is successful, we'll create the JSON web token, and finally from the web API we'll be returning the JSON web token to the client side. So at present inside this Program.cs file, here we have the web API method that we have created for user registration. So let me copy this and let's forward this web API method, and just beneath that we can add this web API method with this URL sign in API/sign in, and here we have the lambda expression to handle the request. Now let me copy paste the parameter from this user registration web API method. We need the user manager. In order to receive these two credentials, email address and password, we are going to create a model class like we have done for user registration. For that, let me copy paste this. This is login model. Inside that we only need email and password. At present this Program.cs file is messy. We will be organizing everything into respective files and folders after implementing this feature. Now instead of user registration model we have login model, and let's rename this parameter also. Now with the help of this user manager we have to find if there is a user with the given credentials or not. So here we go, user is equal to user manager dot find by email async method can be called. Into that we can pass the email from the model that we have here. Now since we have an async method here, we can prefix the method with the avoid keyword, and that requires an async method just before this lambda expression here. Now we have only checked if there is a user with the given email address or not, because we can't check for the received password inside the DB. During the user registration itself, the password is hashed. So for that we'll be using a separate method. So here we have the if clause. First of all, we'll ensure there is a user with the given email address, and here we'll do the password comparison. For that we can invoke this method check password async. As a first argument we have to pass this user object itself, and then we have to pass the password that we have received through the request body. Now this method will check whether the given password is the correct password for the user. Now if it is successful, we'll handle the request inside this if clause here. else will return a bad response. So here we go, return results dot bad request. Inside that we can pass this object message is equal to username or password is incorrect. Now inside this if clause, let's go ahead with generating the JSON web token. For that, first of all, I will save the encoded version of the secret key that we have here into a variable. So here we go, sign in key. Now actually we are already done that inside this JWT configuration options here. So let me copy this and pasting the same here. Now we want to describe the token that we are about to create. So that would be deciding what are the claims or informations that we want to add into the payload. Once the header and the payload is available, the signature could be generated or encrypted with the algorithm that we have specified here using the key that we have saved inside the app settings.json file. So all we have to do is just describe what are the informations or claims that we want to pass into the payload of the token. So here we go, token descriptor. Into it we'll be assigning an instance of this security token descriptor. Now through this property subject, we can pass the custom claims like user ID, role of the user, etc. and etc. So into this property we'll be assigning an object of this class claims identity. And the constructor of the class expect an array of claims. For now we only have a single claim. Inside that we'll be providing the user ID. So here we go, new claim. The name of the claim will be user ID. Now the user object corresponding to the credentials that we have here will be the inside this user object here. From that we can access the user ID. And let's convert it into string format. So at present we only have this custom claim. As per the future requirements, we can add necessary claims into this token generation process. Then after the custom claims, we can set the expiry for the token. Instead of add days, let's invoke add minutes method. So the newly generated token will expire after 10 minutes. And finally, with this property sign-in credentials, we have to pass the sign-in key that we have saved inside this JSON file, along with the algorithm that we want to use for the encryption of the signal part. So here we go, new sign-in credentials. As a first parameter, we have to pass the sign-in key here. Then as a second argument, we can pass the algorithm, security algorithm. This particular algorithm could be passed, SHA-256 signature. So here we have passed whatever we needed for the payload, and here we have passed the sign-in key along with the algorithm that we want to use for the encryption of the signature. Finally, in order to create the token, first of all, we want to create an instance of token handler. For that, we can create an instance of this JWT security token handler. Now let's create the token, security token. From this token handler, we can invoke this method create token. Into that, we only want to pass the token descriptor that we have created here. Now finally, in order to convert this token into a serialized format, we'll create a variable token. So this is the actual token that we want to pass as a response to the post request. All we have to do is from the token handler, we can invoke this method write token. Inside that we can pass the security token here. Now all we have to do is just return the response within this OK method. We have to return it within an object token. Now let's build the project. Now back to the Swagger UI. So here we have the post request that we have just created, API/sign-in. Now click on try it out. Now let's pass the user credentials of the user that we have created in previous video. So email is equal to email@gmail.com. And then we have password. The correct password was string, then a pound symbol or hash symbol. Now in order to test the working of this web API method, let's try with wrong credentials. So I will set the password as string. Click on execute. So here we have the bad request with the message username or password is incorrect. So that is from this else block here. Now before passing the actual password, let me increase the expiry time using the method addDays, so that we can avoid the situation where the generated token will get expired before explaining the related topics. So let me build this project again. So that will reload this API Explorer here. Let's try to make the same request. But this time we are providing the correct credentials, email, then password. Click on execute. Boom. See, here we have the JSON web token. Now let me copy paste the same into a notepad for closer inspection. So first of all, we have the header, then payload, then finally signature. All of them are separated with a dot in between them. So here we have successfully implemented the web API method for login or sign-in operation. First of all, we have checked whether we have a user inside the stored list of users with the given credentials here. And if there is such a user, the web API will create the JSON web token and it will be returned as a response back to the caller. So inside the previous illustration about token-based authentication, we have completed this part here. Now when we make this post request from the Angular app, the received token will be saved somewhere persistently outside the cookie. Most often, browser local storage is used. We will do that in a bit because we need to pass the same for accessing any protected resource from there onwards. And once such request asking for protected resource reach in the web API, the passed JSON web token will be validated inside the server side. Now let's see how the token or token signature is getting validated inside the server side. For that, I will make use of this debugger inside this official documentation. Now let's switch into the dark mode. So this is how it works. If we provide the received token here, the containing header and payload will be decoded here. And with this last portion, we can verify the signature. So let me copy this and pasting the same here. Let's remove the new lines that we have added. Now you could see the decoded header and payload of this token here. Here we have the algorithm that we have used, SHA-256, and here is the type of the token, which is JWT. Inside the payload, you could see the ID, user ID that we have passed inside the web API method. You could verify that from this users table here. See, the same ID is the pass into the payload. Then we have the expiry time as per the configuration we have given during the token generation process. Now other than those two, we have IAT, which stands for issued at time. NBF stands for not valid before, which exactly have the same data that we have inside the IAT, meaning that this token is not valid before the issued time here. Okay. Now you should be careful while describing the token like we have done here. Whatever we pass inside the claims or payload can easily be decoded because the URL encoded format of the payload is directly added to the token. Now the process URL encoding is the process in which the characters that we have is converted into a format that can be transmitted over the internet. To be specific, the converted output from the process should be safe to pass within the query strings of the URL. So that involves replacing special characters in the data with respective encoded versions. So make sure to avoid passing crucial data through the payload. It could be easily decoded by pasting the JSON web token inside this part. Can also be decoded easily with the respective decoding methods. For example, in case of JavaScript, if you pass this payload here into this method atob, we will get the decoded version. Let me try that here. atob, inside that let's pass the string. So here we have the encoded version of the payload. Now let's execute the method. You see here we have the string version of the payload that we have passed inside this JSON web token. You could see the same here also. So that's how easy it is to decode the URL encoded version of the payload or header. Now the actual protection is inside this third part here, signature. Now like we have discussed previously, this signature is formed by encrypting this part here from the starting of the token up to this second dot here. And for the encryption process, we have passed a secret key. Now during the process of validating the token signature, the signature part will be recreated by encrypting this part with the signature that we have saved inside this server side here. Now let me illustrate the same with this debugger's third part here, verify signature. Inside this part, this much portion will be taken as the input for the encryption using this algorithm SHA-256 using the secret key that we provide here. So whatever secret key you provide here, this much portion will be encrypted with the key that we have provided here. And the result will be updated in the signature part of the token. And here you could see the feedback saying signature verified. So meaning that this signature is the exact encryption of this part with the given secret key here. That's exactly how we create the signature. Now whenever we change any of these values inside this header or payload, you will get this feedback invalid signature. Meaning that encrypting this much part with this given secret key does not match this signature here. So that's how the debugger validation feedback works. Let me undo the change that I have done. Now let's go ahead with the actual procedures involving invalidating a token signature. Inside this notepad we have the original JSON web token. So during the verification of the signature inside the web API, this much part will be encrypted with the key that we have saved inside this app settings here. And then the resulting signature will be matched with the received signature. Let's see them in action inside this debugger. For that, first of all, I will clear this signature. Now let's copy paste the secret key inside this debugger here. Now this signature will be matched with the received signature. See, both of them match each other, and thereby the verification of the token signature is successful. The user will get access to the protected resource, and if needed they can make use of the information that is received through the token payload. Now let's see how much safe is a JSON web token. Suppose a hacker got this token from someone successfully authenticated to the system. They can easily decode the payload, and if they want to change any of the information like user ID, role or whatever it may be, they can do it without a problem inside the payload. But during the token verification process, it will be caught because inside this signature, the original payload is encrypted. So anyone outside the server can't do anything without the secret key that we have saved inside the web API. So this token is protected by itself because there is a signature of the actual data passed through the token. So hope you understood how the token signature is getting verified while accessing a protected resource. Now this will be done in action while doing the authorization. We'll discuss that in the next video. Now back to VS Code and let's make a post request to this web API method sign in from this Angular app login form submit event. So here we have the login form submit event. We'll make the post request if the form as a whole is valid. So here we have the if clause. Inside that we want to check whether the form as a whole is valid or not. Now to make the post request, back to the auth service clause. Here we already have a method create user for making the post request for the user registration. Now let me copy paste that for making the post request to the sign in web API method. So here is the function sign in, and here we have the parameter to receive the form data, and this will make a post request to this given URL here /signin. Along with that we'll pass the form data having the email and password. And the return observable from this post method, we have returned that from this function sign in. Now back to the login form component. First of all, we have to inject the service clause here. Private service, which is of the type auth service. Now back to the function on submit. Let's invoke the method signin, service.signin. Into that we want to pass the form data. Now we can make the subscription to the return observable like this. With this next property, we can pass the success callback having a single parameter response which is of the type any. And with this error property, we can pass the error callback. If there is a user with given email and password, the authentication will be successful. So we can handle that inside the success callback here. So inside the return object, there will be a property called token, which we have already seen while making the post request inside the Swagger UI. So the return JSON web token will be there inside this property. Now we have to save this into the local storage. For that, we can make use of the setItem method from the local storage. As a first parameter, we have to pass a name for the key that will be token, and then second parameter will be the value that we want to save into the token. So let's pass this token here. Now after the successful login operation, we want to redirect the user to the dashboard, which we have already created here, dashboard component. So first of all, let's add a corresponding route inside this app.routes. For now, I will do this path is equal to dashboard, and we want to render this component dashboard. So this component, dashboard component, will be replaced inside the router outlet inside this default app component here. Okay, so back to the login component. In order to redirect from this component, first of all, we have to inject router into this component constructor. So let's add the corresponding constructor parameter router. Now inside the method, we could do this router.navigate by URL method can be called. Into that, we just need to pass the path that we have given for the component dashboard. So this is how we handle a successful login operation. Now suppose there is no user with the given credentials, then from the web API we are returning a bad request. So the corresponding response status code will be 400. So with that, we can catch the error or response inside this error callback here. If the error status code is equal to 400, we want to show a toaster notification. So first of all, inside the component constructor, let's inject the toaster service. Private toaster, which is of the type toaster service. Now we could do this toaster.error method can be called. As a message, we can pass this incorrect email or password. And here we have the title, login failed. Now if there is any other error, we can handle that inside this else block. We will just print the error object like this. Let's save this. Back to the app. Let's open the developer console. First of all, let's start with incorrect user credentials. Submit the form. See, here we have the toaster message, incorrect email or password. Now let's start with the proper user credentials. email@gmail.com, and here is the password. Submit the form. Boom. See, here we are redirected to the dashboard. If you check the local storage, you should see the respective JWT token that we have just created as part of this successful authentication. See, inside this local storage, here we have the JSON web token that we have just saved as part of the recent login operation that we have made. Now inside this dashboard, we have to deal with the logout operation. We'll do that in a bit. Before that, let's implement the Angular fade-in animation inside this navigations, sign in and sign up. So basically the animation is going to be applied into the content that we are going to render inside this wrapper div here. At present, we have sign in and sign up form. In future, we may also want to implement the provision for forgot password. To do that, we'll be adding one more child component to this parent component user. So we'll be showing the same inside this same wrapper div here. So the animation will be applied to this parent component to this div here. So whenever there is a change of component rendered in place of this router outlet, there will be a fade-in effect. If you want to know more about Angular animations, you can go to this official documentation here. So as you know, we are going to apply the animation inside the parent component user. So first of all, open the corresponding TypeScript file. First of all, inside this app.config.ts file, we have to provide the necessary dependency injection related to the animation, which we have already done as part of the toaster service. So don't forget to invoke this method inside this app.config file. Now back to the user component. First of all, inside the component decorator with this animations property, we have to define the requirements of the animation. For that, we can pass this array. To define the animation, first of all, let's import the necessary functions from Angular animations. So these are the functions: trigger, style, animate, transition, and query. From the name of this function, you could tell what's their purpose. So with this function trigger, we'll define the animation. As a first parameter, we have to pass the name of the animation, that will be router fade in. Now with this second argument, we can define the animation that we want to do. So here we have the animation transition, and that will be happened when this condition is met. It's like a wildcard expression. The exact meaning will be discussed later. Now whichever transition we want to do when this condition is met, we can pass that as a second argument inside this array. So here we have invoked this method query. Inside that we have an expression. You could think of it as a selector. So with this selector :enter, we are going to apply the animation on the element that is being added to the router element here. So that will be the new component replacing the previous component. So the new component will get the fade in effect. Now with the second argument array, we can pass the animations. First of all, we have set the opacity to 0. So initially, the component that is being rendered, its opacity will be set to 0. And then within 1 second, it will be gradually within 1 second, the opacity will be incremented to 1. Now as a third argument to this query function, we'll pass this object having this optional set as true. Meaning that we don't want an error when there is no component with this given selector. So this is how we define an animation. If you want to know more about any of these animations functions, you can go to the official documentation and search for the function like transition and look for the reference article transition. You could do the same for rest of the functions also. Now with this animation defined here, let me copy the name of the animation. Back to the component HTML, this is what I'm gonna do. I will pass the animation with a prefix @simple like this. Into that, we want to pass an argument. So that will be the value returned from this function getRouteURL. I will tell you how this works. First of all, let's define this function. So back to the component TypeScript file, and here is the method getRouteURL. Now this function should return the current URL of the app. To retrieve that, first of all, we have to inject the children outlet context. So here we go, private context of the type children outlet context. If you want to know more about this class, you can go to the official documentation and let's search for the same. See, it stores the contextual information about the children, meaning that whatever the route URL for these children can be received with this class object children outlet context. So here we go. From the context, we can invoke this method getContext. Into that we'll pass primary. So that is referring to the detect children. From that, we want to retrieve the route and let's return the URL. So this function will return the URL of this router outlet context, and we have assigned that to the animation that we have defined. So that will be considered for the condition that we have defined here, this one. So whenever there is a change of URL inside the router outlet, this animation will be executed. So hope you understood how the animation works. Let me save this back to the app. At present, we have not given a proper URL. So let me set the default URL as the login component. So here we go, path is equal to empty. Then we want to redirect to /signin. Make sure to set this property path match as full. Sorry, here we have a typo, sign in. Save this back to the app. See, during the back and forth navigation, we have the fade in effect. Now let's go ahead with implementing the logout operation. For that, first of all, inside the dashboard component, let's add a button for logout. So here is the component HTML. Instead of this default paragraph, we have a button having these bootstrap clauses btn, then btn dark. Inside that, we will show this logout. And let's fire up a click event. We will handle the click event inside this function on logout. Now let's define this function inside the TypeScript component. When the user is successfully authenticated to the system, we only save the token into the local storage, as you can see here. So during the logout operation, we will do the reverse. Let's copy this statement back to the component dashboard. Let me paste that here. In order to remove the token with this key token, we just need to invoke this method remove item. That's it. Now after that, we want to redirect the user back to the login form. For that, first of all, we have to inject the Angular router. So here we go, private router of the type router from Angular router. With that, we can invoke this method navigate by URL. Into that, we can pass this path /signin. Let me save this back to the app. Here we are inside the dashboard already, and you could see the logout button here. Now before trying it out, let me open the local storage. So application, and here we have the local storage. Within the key we have the JSON web token. Now click on this logout. See, here we are redirected back to the login form. At the same time, the token is deleted from the local storage. Now as part of authentication, we have to set up protected routes inside this Angular app. For example, the user must be prevented from directly accessing the dashboard through typing the URL like this. We'll do that later as part of authorization. Along with that, we'll be adding a neat layout for the dashboard component here. Now finally, back to ASP.NET Core Web API, and let's organize whatever we have inside the Program.cs file into respective files and folders. So we are going to convert this Program.cs file from this to this. So that's what we are going to do in this third section. Before getting into that, we should be familiar with the C# extension methods. Keep in mind that it's not static methods, the feature is called extension methods. Now consider this part as our Web API project. Into that we have added a necessary framework called ABC. Now suppose inside that we have an interface or class called original. The implementation of this type original is already done within the framework with its own methods and properties. Now using the C# feature extension method, we are going to extend this type original by adding our own methods from this Web API project here. Say we have an object org1 which is of the type original, that is from this framework here ABC. Now using the C# extension methods, we have added these two methods into the type original. Now let's see how it is done. So first of all, we have a static class. Inside that we have two extension methods for this type original. All we have to do is the method must be static and the first parameter to the method should be of the type original. And make sure that the parameter is prefixed with this keyword this. Then such a method will act as a method defined inside the type original. And that's how we are able to invoke these two methods from the same type. Even though both of these methods are not there inside the original implementation inside the framework here, we could add methods like this from our Web API project like this. Finally, there is a warning. Make sure that there is no such method already present inside this original implementation here. We can't override an existing method with this feature extension methods. Now we are going to make use of this feature for organizing the Program.cs file. Now first of all, inside this Program.cs file, let's add extension method to the type of this services collection. You could see that it is having the type of this interface iService collection. So to be specific, we are going to add an extension method to this interface iService collection. For that, first of all, I'm going to add a new folder called extensions. Now inside the new folder extensions, we are going to add a C# class file corresponding to this outer static class here. So here we go. Inside the new class we are about to create, we'll be adding extension method related to ASP.NET Core Identity. So I will name this class as Identity Extensions. Now, some of you might have noticed it. The outer static class name is nowhere mentioned while invoking these containing extra methods. See? And for the same reason, we should be providing some meaningful name for the outer class, like we have given here. Inside this class, we'll be only having extension method related to ASP.NET Core Identity, and thereby you could easily navigate the extension method inside the project. So first of all, we have to make the class as static class identity extensions. Now I'm going to add an extension method for what we have done here, in which we have added services for identity handlers and corresponding entity framework stores. So here is the new extension method, public static void. I will name the method as add identity handlers and stores. Now we have already made this method as static like we have seen here. Now we also need a parameter of the type iServiceCollection, which is the type of this services here, iServiceCollection. So here we go, iServiceCollection, and I will name this parameter as services. As a prefix, we have to use this keyword this. So here we go. Now this method add identity handlers and stores became an extension method of this type iServiceCollection. So you can invoke this method from this type iServiceCollection from this program.cs file like this. Builder.services.add identity handlers and stores. So this is the method that we have just added, the extension method. Now let me cut this and pasting the same inside this new extension method. The iServiceCollection is already here as a parameter, so we can invoke these methods from these services here. So here we go, services dot add API endpoints and then add entity framework stores. So this is how we are going to add extension method throughout this program.cs file. Now the proper naming of extension methods like we have done here will help you to remove comments like this. Now here we have configured the properties of user, password and email address for user registration. So to do the same, I'm going to create another extension method. For that, I will just copy paste the signature of this method. I will name this method as configure identity options. Let's move this statement into the new method. We can invoke this method from this services parameter itself. So here we go. Sorry, here we need an extra curly bracket. That's it. Now we can invoke this new extension method from this program.cs file. Builder.services configure identity options. So hope you are realizing that how C# extension method is helpful to organize codes like this. Now we could make this even more better. Instead of returning void from this extension method, we can return this interface type iServiceCollection. So at the end of invoking these methods, we have to return these services like this. Return services. Let's do the same for the second extension method also. We have set the return type as iServiceCollection, and after invoking these methods, we have returned the services here. Now by doing this, instead of invoking these two methods separately from the services, we can change the invocations like this. This method is already returning an iServiceCollection. From that, we can invoke this second extension method. So all we have to do is just change the invocations, method invocations like this. Okay. Now let's define an extension method for injecting the DB context here. It's not related to identity, so I'm going to create a new C# class file, entity framework or extensions. Let's make this class as static. Now here we have the extension method public static Now instead of defining from start, let me copy this signature from here. I will name this method as inject db context. Now let's move this statement for the db injection into the new extension method here. We can invoke this method add db context from the service parameter. Let's add the required using statements. Now to this method useSQL Server, we have to pass the db connection string that we have saved inside this JSON file here. For that, we have to pass this configuration from the Program.cs file. So first of all, let me add a parameter of the type iConfiguration. Let it be config, and we can invoke this method getConnectionString from this config object. At the end of this method, we have to return the services. So here we go, return services. Now let's invoke this method inject db context from this Program.cs file. That we can do through chain invocations like this. Into this method, we have to pass the builder.configuration object. Now instead of naming this method as inject db context, we could have named it like add db context. But such a method is already present inside the type iService collection. That's what we are invoking here. So that's the reason why we have named it like inject db context rather than add db context. As I already told you, we can't override an existing method with an extension method like this. Now, in previous video, we have added authentication services from ASP.NET Core with this method invocation. Inside that, we have given necessary configuration for JSON Web Token authentication. For that, I'm going to create a new extension method inside this identity extensions. First of all, I will copy paste this last extension method. And let's clear everything inside that. I will name this method as add identity auth. Often I use this abbreviation auth to mention operations combining both authentication and authorization. At present, we have only added the authentication services. In next section, we'll also be adding authorization also. So that also will be done inside this method add identity auth. So let me cut this and paste the same here. Let's invoke the method from services parameter. Now here also we need the configuration object. So we have to add the second parameter like we have done here. Let me copy this and pasting the same here. Now let's replace this builder.configuration with config. Now back to the Program.cs file. Let's invoke the new extension method add identity auth. As an argument, we have to pass the builder.configuration object. Now if possible, change the order of invoking this method for better grouping. Everything related to identity will be called in sequential order. So first of all, I will invoke this inject db context. Then we have add identity handlers, then configuring the identity options, and then we have added the services for authentication and authorization. As you can see, the Program.cs file is already getting cleaned. Now, as the next step, we want to add extension method to the type of this app object. Before doing that, I want to add one more extension method for statements related to Swagger UI. For that, I'm going to create a new C# class file, Swagger extensions. So here we have the static class. Now let me copy paste an already existing extension method. I will name this method as add Swagger Explorer. Let's clear everything inside the method and let's cut and paste what we have here. Let's invoke this method from this services parameter. Now let's invoke this method inside the Program.cs file. Add Swagger Explorer. For now, I would like to keep this add controllers method as it is. Now we need to add few more extension methods to the type of this app object. First of all, here we have the if clause to configure the Swagger API Explorer. For that, I'm going to add a new extension method to the Swagger extensions here. Let me duplicate this last extension method. Previously, we have been adding extension method to the type of this iService collection. But in case of this app object, we have to add extension method to the type of this class web application. So we have to change this parameter accordingly. Instead of this interface, we want to extend this class web application. I will name this parameter as app. We want to return the same type from this method. So let's change the return type to web application. Now let's rename this method as configure Swagger Explorer. Let's empty the method, and finally from this method we'll be returning this app object. Now let's move this if clause into the new method here. Now we can invoke the method app.configure Swagger Explorer. Now inside this region we have configured the course middleware for the Angular app. So let's create an extension method for the same. For that, into this extensions folder, let me add a C# class file app config extensions. So here we have the static class. Let me copy paste the last extension method that we have created here. I will name the method as config course. Let's clear the method. Now let's move this use course method invocation into this new extension method here. Now we don't need this region anymore. Now we can directly invoke the method here config course. Now you know what, for configuring the course we may need data from this app settings.json file. So in those situations we have to pass the configuration object like we have done here. So let me copy paste the same here. Now we have to add the necessary parameter inside this extension method. iConfiguration as config. Okay. Now let's add our final extension method for adding these authentication and authorization middleware. That we can do inside this identity extension clause. For that, first of all, let me copy paste this extension method into the class here. I will name the method as add identity auth middlewares. Let's clear everything inside the method and let's move these two method invocations into it. Let's cut this and paste the same here. Now let's invoke this new method like this. Actually, we could change this method invocation to the invocations here, so I will do this. So far, with the help of C# extension method, we have organized every method invocations related to adding services and configuring services like this. Now, rest of the portions inside this Program.cs file deals with Web API methods. First of all, you could see this method invoked here, map controllers. It will configure or add routes from traditional controls like this weather forecast control. This is the default control that's already been there inside the new project template. So the routes from conventional Web API methods like this will be added with this method invocation here, map controllers. But so far inside this project we have used minimal Web API methods, and that's how we are able to define the methods inside this Program.cs file itself. But doing all of them here kind of mess up the whole purpose of Program.cs file. So let's organize these Web API methods properly. Now before this user registration and login Web API methods, you could see this method invoked here, map identity API. We have invoked this method for adding routes from identity framework into this project. And rest of these Web API methods are custom Web API methods that we have added throughout this series. Now let's look how to organize these Web API methods or the web API methods that we are about to add going forward in this series. We are going to use the same concept that we have used so far, that is C# extension methods. Let me walk you through it. Inside this controllers folder, I'm gonna add a C# file. I will name it as Identity User Endpoints, like we have done for these extension classes here. We are going to make this class as static. Now inside this class we will be adding web API methods related to the entity identity user. For that, first of all, let me copy paste an extension method that we have already created here. So far we have been adding extension method to the class web application or the interface iService collection. But in order to work with minimal web API methods, we have to extend this interface iEndpoint router builder. I will keep the parameter name as it is, app, and I will set the same type as the return type of this method. Now let's rename this method as map identity user endpoints. Let's clear everything inside the method. So as I said already, inside this class we will be adding web API methods related to the entity identity user. So both of these web API methods will be added into this class here. So from this Program.cs file we can invoke this method map identity user endpoints. Now you might be asking this, here we have added this extension method to the type of this interface iEndpoint route builder. But here in this Program.cs file we have invoked the method from the type of this app, which I present inside this Program.cs file, which is having the type of this class web application. How it is possible? It is possible because this interface here is a derived type of the class web application. See, this interface is derived from this class web application. So the parent type can invoke the children methods. That's what exactly happened inside this Program.cs file. We have already done the same while defining these two web API methods here. This method map_post is actually a method of this interface iEndpoint route builder, and here we have invoked it from the parent type app, which is having the type web application. See? So let me move these two web API methods into the new method here. Along with these web API methods, we also need these two classes. So let me cut this and pasting the same outside this class here. Now let's add the required using statements. Now here you could see an unresolved error due to this builder object. It was readily available inside this Program.cs file, but inside this endpoint class it's not available. We'll fix that in a bit. Now we can organize these web API methods even more better. For that, outside this extension method, I'm gonna create a private method like this, private. This class is already static, so the containing method should also be static. And here we have the method create user. Now we are going to move this lambda expression into the new method that we have created here. For that, first of all, I will cut everything inside this lambda expression and pasting the same here. And let's cut these parameters here. Now from this method we are returning an HTTP response, so we have to provide the corresponding return type for this method. That will be task of the type iResult. Now all we have to do is just replace this method in place of this lambda expression here. Now since the method contains asynchronous operations, we have to prefix the method with this async keyword here. Now let's do the same for the second web API method for the sign-in operation. Let me copy this method signature from here. I will name this method as sign-in. Now we have to replace the method parameters with what we have inside this lambda expression. Now let's move everything what we have inside this lambda expression. Now instead of this lambda expression, we can pass this method sign-in. That's it. So with this method invocation inside this Program.cs file, map identity user endpoints, we have mapped every web point related to the entity identity user. At present, it contains the web API methods for user registration and sign-in operation. Now, in order to avoid repeating this part of the URL in all of the web API methods, I will invoke this method map group before registering the web API endpoints like this. So all of the containing web API methods will get this prefix in the URL. So we no longer need to repeat this part of the URL /API. So this is how we are going to deal with web API methods. Now of course inside your project you will be dealing with different entities. Suppose you are creating this web API for an e-commerce website. In those situations you will be dealing with orders. So to define web API methods related to the order, you will be creating a separate class like we have created here. For example, let me add the class file order endpoints. You will change this class into a static. Inside that you can define an extension method like we have done here that will be map order endpoints. So all of the web API methods related to the order can be added to the extension method like we have done here. At the end, in order to add such web API methods into the project, we can invoke the extension method map order endpoints here. So that's how to deal with web API methods. Now finally, we have to resolve this error related to accessing configuration data from the builder object. This builder object is not available inside this class here, identity user endpoints. But we could pass the builder object from this Program.cs file like we have passed the builder.configuration in rest of the extension methods here. But that's not a best practice when it comes to web API methods, because we will be passing first to the map method here. From there we will be passing the same to this method sign in. In order to avoid the inconvenience in passing the builder object, we can make use of dependency injection. Let me show you the proper way to do it. For that, first of all, I'm going to define a class representing the data inside this app settings.json file. Because inside these methods that we have created here, it is trying to access the configuration values. So first of all, I'm going to define a class inside this models folder, app settings. At present, with this class, I want to represent this key here, app settings. As you go further with the app development, you will be adding more key value pairs into this app settings. So all of those properties could be added to this class here. So at present, we only have this property JSON secret. So let me copy this and let's define a property with the same name, which is of the type string. So here we have created a property with the same name as that of this key here. Now back to Program.cs file. Now like we have injected an instance of this DB context, I'm going to inject an instance of this class app settings with the corresponding value that we have inside this app settings.json. So here we go. From this services collection, we can invoke this method configure. Now here we have to provide the type of this class app settings. Now into this method, we have to pass this section here, app settings. So here we go, builder.configuration.get section method can be called. Inside that, we can pass this section, app settings. So with this statement here, an instance of this class app settings will be created, and the containing properties will be assigned with the value with the corresponding key value pairs from this section here. Now any web API method can access the properties inside this app settings if there is a corresponding parameter inside the web API method. So for example, for this web API method, sign in, we have to access this JWT secret. So we can do this to this method. We'll add this parameter iOptions of the type app settings class, and we'll name this parameter as app settings. Now in order to read this key JWT from the JSON file section app settings, we could do this app settings. Inside that we have this object value which is corresponding to the class here app settings. From that we can access this property JWT secret. See, that's simple. Like this you can access any property that is added to this class app settings. So that's how to do dependency injection for properties or values or informations inside this app settings.json file. Now finally, let me move this into a new extension method that we can do inside this class app config extensions. For that, let me copy paste this extension method for the DB injection. I will name it as add app config. Let's clear the method. Let's cut this and paste the same inside this new extension method. Instead of builder services, we can make use of the services parameter. We already have this object inside this parameter config. That's it. Now let me invoke this extension method just after the injection of the DB context. Here we have to pass the configuration object builder.configuration. That's it. So that's it guys. In this program.cs file we have organized everything into respective folders and files with the help of C# extension method. So before going forward, let's verify the proper working of the web API methods that we have done so far inside this project, that is user registration and user login. So let me run this project. First of all, let's create a new user. Let's make the request. So here we have successfully created the user. Now let's try to log in with the same credentials. For that, here we have the post request sign in. Try it out. Let's make the post request. Boom. So here we have the JSON web token as a result of successful authentication. Now in this section, we'll discuss all about authorization. First, we will see how to restrict Angular routes only for logged in users, and then we'll be consuming a protected web API endpoint from Angular by passing the user token. After that, we'll thoroughly discuss how to implement web API authorization with role, claim, and policy. To demonstrate the same in Angular, we'll create respective components and corresponding routes, and they will only be made accessible if the user has the necessary permissions. And then we will show how to hide HTML elements based on user claims or user permissions. And finally, we'll discuss how to handle unexpected request responses like for node 1 and for node 3. So without further ado, let's get started. First of all, we are going to discuss how we can make an Angular route protected or private based on whether the user is already logged in or not. For example, let me log out from this application. At present, we are not authenticated to the app, but if you try to access this component or this route dashboard, you will get the access. It should be prevented. So that's the first thing that we are going to do in this section. So basically, we are preventing unauthenticated access to this Angular app. After that, we can do the same in necessary ASP.NET Core Web API methods. So in order to prevent unauthenticated access to Angular routes, we'll be making use of Angular guards. You could see the same inside the documentation here. Inside docs, inside this routing, go to common routing task, and then under this subheading, prevent unauthorized access, you could see the detailed explanation. Starting with creating an Angular guard. So as per our app structure, we'll be creating the auth guard inside the shared folder like this. Let me open the terminal. G for generate, and we want to create a guard, and that should be inside the folder shared, and we want to name it as auth guard. Hit enter. So basically within an Angular guard we'll be adding some conditions or criteria, and that will decide whether we want to allow or disallow the access to the route that the user is trying to access. And within an Angular guard we can implement any of these functions here. Each of them has different use cases. You will know better as we go further. Now select the types of methods that you want to implement inside the guard. For that, we can make use of the space bar like this. For now, I only want to implement this canActivate method. Now hit enter. So here we have the guard that we have just created, auth guard. So at present, auth guard is a function having this type here, canActivate. Now with this auth guard function, we'll be preventing unauthenticated access. So first of all, let's apply this guard to all the routes that we want to prevent from unauthenticated access. At present, we only want to make this dashboard route as protected. Now since this auth guard is of the type canActivate, we have to pass this function inside an array having the name canActivate. So here is the array canActivate. Inside that, we can pass the function inside an array like this, auth guard. So any route having this auth guard passed to this canActivate will only be accessible or made available to the user if this auth guard returns the boolean value true. Now back to the auth guard. Inside this, we want to check whether the current user is already logged in or not. In order to check whether the user is already logged in or not, we only want to check whether we have saved a JSON web token inside the local storage. For that, I'm going to define a function inside the auth service is logged in. So here we have the return statement with a boolean expression. From the local storage, we want to retrieve the JSON web token that we have saved during the login operation. If it is not null, we'll return true, meaning that the user is already logged in. Else, we'll return false. Now back to auth guard, and let's invoke the method that we have just created. For that, first of all, we have to inject the auth service. Unlike a class, there is no constructor inside the function to do the normal way of dependency injection. For that, we can do this auth service. Now to inject an instance of the auth service, we could invoke this method inject, and let's pass the name of the service auth service. Now let's invoke the method that we have just created is logged in. If the user is already logged in, we'll return true. Else, we'll redirect the user to the login page. For that, first of all, we have to inject the router. Inject router from Angular router. Now inside this else block, we can redirect the user to the login page. Navigate by URL. Inside that, let's pass /signin. And finally, we have to return false. Now let me save this and back to the app. If you try to navigate the dashboard route, you will be redirected back to the login page again. See? Because you are not authenticated into this application. So from now onwards, in order to access any protected route, first of all, you have to authenticate it to the app like this. Boom. That's it. Now we have to do the same protection inside the ASP.NET Core Web API also. Now before doing that, I want to make some adjustments in the code that we have already written. First of all, inside the function that we have just defined is logged in, we have hard-coded the key name as token. It's not a best practice. If you want to change that in future for some valid reason, you have to do the changes in each of the places you have used it. So considering the situation, I'm going to update the app structure like this. Inside this shared folder, I'm going to add a new file, constants. This auth guard is already created. Now we're going to create this file, constants. So here we have the shared folder. Let's create the file, constants. Inside that, we can create and export a constant with this name, token key. So this is a best practice while naming constant variables. All the letters are in uppercase. Now into this variable, we can assign this value here, token. Now instead of hard coding, we can make use of the variable like this, token key. Now in previous video, we have hard coded the token as token, which you can see inside the components like login. See? So what I'm going to do is I'm going to define separate functions to save or retrieve the value of the token into the local storage. So first of all, let's find all of the places where we have used local storage. So go to menu, then find in files, and let's search for local storage. So first of all, we have the dashboard component. During the logout operation, we have removed the token value. So let's define a function for the same. So go to the auth service. So here is the function delete token. From local storage, we can invoke this method remove item. Inside that, we want to pass the name of the key that we can access from the constant variable token key. Now back to the dashboard component. Let's inject the auth service here, private auth service of the type auth service class. Now let's invoke the method that we have just created, auth service dot delete token. Now inside the login component, when a user is successfully authenticated to the system, we have saved the user JSON web token like this. So let's define another function for saving the token. So here is the method save token, having a single parameter token of the type string. Inside that, we could do this local storage dot set item. First of all, we'll pass the key name token key. As a second argument, we can pass this token parameter. Inside that, we have the JSON web token. Now back to login component. First of all, we have to inject the auth service, which we have already done as service. So here we go, service dot save token. As an argument, we can pass the token that we have received from the post request. So that's all for now regarding the best practices in retrieving and saving the JSON web token. Now back to what we have been doing. With this auth guard, we have prevented any unauthenticated access to this Angular app. All we have to do is just pass this auth card to the route that we want to make it protected or private, just like this dashboard. So from now onwards, this dashboard will only be available for authenticated users. Now I have some sort of the reverse requirement. That is, when an already logged in user tries to access the routes, sign in or sign up, we want to redirect the user back to the dashboard. So back to the login component. For that, we can make use of the ng onIt lifecycle hook inside the component. So first of all, let's implement the interface onInit. Now let's define the function ng onInit. Inside that, first of all, we'll check whether the user is already logged in or not. For that, we can make use of the method from the auth service is logged in. If that's the case, we can make use of this router to redirect the user back to dashboard. So router dot navigate by URL, and let's pass the route /dashboard. Now let me copy this and then open the component registration. Let's implement the interface onInit. Now let's paste the method that we have copied from the login component. Inside this component, we have not yet injected the router, so let's do that. Private router of the type Angular router. Save this, back to the app. Now if you try to access the routes, sign in or sign up, you will be redirected back to the dashboard. Now we have to do the same in ASP.NET Core Web API, that is preventing Web API endpoints from unauthenticated access. That is what we often refer it as authorization. So let me start with comparing the process of authentication and authorization. Authentication verifies whether a user is an insider or not. Now the process authorization grants access to protected resource only if the user has necessary permission. We have already discussed authentication in great depth and implemented the same in previous section. Now let's deal with authorization. Now you could see the same comparison inside the official documentation. Authentication is the process of determining a user's identity, while authorization is the process of determining whether a user has access to a resource.
Like we have seen, during the process of authentication, the user will be making a post request with their own login credentials, and then the identity management solution will check whether there is a user with the given credentials or not. So that's the process of determining a user's identity. Now each user inside the system will be allocated with different roles or different permissions. Now in order to access a protected resource, the user must have the necessary permissions that the protected resource is asking for. So based on whether the user has the necessary permissions or not, authorization will grant or deny the request to access the protected resource. Now let's see them in action. Now we can divide WebAPI methods into three categories based on how we apply the authorization to them. So first of all, we have WebAPI methods that does not need any type of authorization. For example, consider the endpoints like user registration or sign-in. All of these should be open to anyone without any authorization criteria. And then we have the second category of WebAPI methods asking the basic or minimal criteria for authorization. That is, the user must be authenticated to the system. In case of JSON Web Token authentication, in order to access these types of WebAPI methods, the user must pass a valid JSON Web Token. So this authorization is asking for the minimal or basic criteria. We have just implemented this feature inside the Angular client side with the auth guard. Now let's do the same inside this ASP.NET Core Web API. For example, consider a getWebAPI method to retrieve user profile data. This endpoint should be accessible to any authenticated user. And then any WebAPI method asking authorization criteria, anything extra from being authenticated to the system, comes under this third category of WebAPI methods. So the criteria will include role, claim, and policy. We'll be discussing them in great depth. So first of all, I'm going to make a getWebAPI method for user profile, and it should be accessible to anyone authenticated to the system. So back to Visual Studio. First of all, I'm going to create a C# file for account endpoints. Now, like we have discussed in previous video, let's change this class into static. Now let me add an extension method like we have done inside this identity user endpoints. Let me copy this and pasting the same here. Let's rename this method to map account endpoints.
We have already discussed these best practices in previous section.
Now we're going to make a get request, so we can invoke this method map get, and the corresponding endpoint will be like this, user profile. Now we can handle this request inside this private method get user profile. So here is the method private static get user profile. For now, from this method we'll only return this string user profile. So let's change the return type of this method to string. Now in order to register this endpoint to this web API project, we have to invoke this method from this Program.cs file. So here we go. So here we have a getWebAPI method user profile. From that we are returning this string user profile. Now in order to restrict this WebAPI method to the authenticated user, we can invoke this method require authorization, or we can apply this authorize attribute. Authorize attribute can be applied to the method that is handling the request. Let me build this project. Back to the API Explorer. So here we have the new getWebAPI method user profile. Now if you try to access this WebAPI method, you will get this error for node 1 unauthorized, meaning that you are not passing the minimum criteria for authorization, that is being authenticated to the system. So along with making this get request here, we have to pass the JSON web token that we get from sign-in operation or login operation. So first of all, let's sign in into the application. We have already created a user with these email and password, email@gmail.com. Then the password was string, then followed by #simple. Let's make the request. So here we have successfully authenticated to the system. As a result of that, we got the JSON web token. Let me copy paste the same into Notepad. Now, along with making a GET request for this user profile, we have to pass this JSON web token. Just now we have created a login operation and we got a JSON web token. Now we're going to make a request for accessing a protected resource. So inside the authorization header, we have to pass the JSON web token like this that we have just received. Upon reaching the request at the server side, it will validate the JSON web token, which we have already discussed in our second last video, explaining how much safe is a JSON web token. And we have already configured how this token validation is to be done while adding the authentication service. So inside this extension method, we call this method add authentication, and while invoking this method add JWT bearer, we have configured how we want to validate the JSON web token. And here we have specified what are the schemas that we are using for different handlers inside the identity solution. If there are multiple schemes involved in the process of authentication and authorization, you can set them separately like this. Since all of the handlers inside this project is managed by JWT scheme, we only need to pass the JWT scheme here instead of this lambda expression here. JWT bearer defaults.authentication scheme. Now here we have specified that we don't want to save the token inside the server once the token is generated. And through this token validation parameters, we have specified how we want to validate the JSON web token once it reaches the server as part of accessing a protected resource. So of course, we want to validate the token signature, and for that here we have given the secret key. Now along with this, I forgot to disable the validation of token issuer and token audience. So I will set this validate issuer as false and then validate audience. To explain in simple terms, while creating the JSON web token inside the sign-in operation here we have only passed the user ID. Along with that, we can pass the issuer, meaning the URL of this web API from which we have created the JSON web token, and the audience, meaning the URLs of the client-side applications. So if you want to make sure the issuer or audience that you have passed inside the JSON web token is the inside the received JSON web token here, we can set this validate issuer and validate audience to true. By default, these boolean properties is having the value true, so that's why we have set it as false here. Now it's time to make the HTTP request to access the protected resource. Along with the request authorization header, we have to pass the JSON web token. For that, if you have an API Explorer other than Swagger, then the process of making the GET request will be much easy. Let me show you how it is done. At present, we are not passing the JSON web token, so let me make the GET request again. Now, let me copy this URL. At present, inside my system, I already have the API Explorer Postman. From that, you can make the request like this. We need a GET request, and here is the corresponding URL. Inside this authorization header, we can set this bearer token. Then inside this text box, just pass the token that we have received. Let me copy this and pasting the same here. Send the request. Boom. We got the success response containing the string that we have sent from the web API method here. Now if you want to see what's happening behind the scene while making this request, you can open this code panel here. Just expand it. See, while making the GET request inside the header, authorization header, the token is passed here. As a prefix, we have this bearer. Just like what we have mentioned here. The same syntax should be used while passing the JSON web token inside the authorization header. You can achieve the same if you have installed the VS Code extension Thunder Client. Let's make a GET request. And here is the URL. Inside this auth header, we will select this bearer and we can just paste the token that we have received. Send the request. Boom. Now coming back to our Swagger API Explorer, we don't have a direct way to modify the request header. If we want to achieve the same, we have to do the necessary configuration while adding the Swagger API Explorer inside the project, which we have done inside this extension method. We have to pass the necessary configuration inside this method add swagger gen. For now, I will just copy paste the configuration that we need for sending the bearer token. So here we go. Here we have the lambda expression with this options parameter. You can copy paste this from our GitHub repository. Let me build this. Now inside the API Explorer, you could see this option for adding the bearer token. So first of all, we have defined a security definition with the name bearer. Inside that, we have set inside the authorization header, we want to pass the bearer token for JWT authentication. And for all the Web API methods, we have given a security requirement for the bearer token. And that's the reason why along with all of these endpoints, you could see this log icon. So that's all about configuring the Swagger API Explorer for passing the JSON Web Token. I'm not getting into the detailed explanation. We are not focusing on Swagger API Explorer. You can just copy paste this code from our GitHub repo. So from now onwards, in order to access any protected resource, first you have to set the bearer token inside this text box here. So let me copy this JSON Web Token and pasting the same here. Click on Authorize. That's it. From now onwards, for all the requests, the authorization header will be set with the token like we have seen here. Now let's try to make the GET request. Boom. That's it. See how the JSON Web Token is passed inside the authorization header. So far we have discussed how to deal with the second category of Web API methods. Now in any given Web API project, most of the Web API methods will come under this category. That is Web API method asking the minimum criteria that user must be at least authenticated to the system. So in order to avoid repeating this authorized attribute, we will apply this authorized attribute globally across all the Web API methods. Let me show you how it is done. For that, back to the Program.cs file. Here we have already added the authentication service into the project by invoking this method add authentication. Now along with that, we have to add the services for authorization. So here we go, services.add authorization. Now in order to set this authorized attribute globally across the Web API, we can have this lambda expression with this parameter options. All we have to do is just define a fallback policy. You could think of policy as a criteria. Into that, we have to assign an instance of authorization policy builder. Along with that, in order to set the authentication scheme, we have to invoke this method add authentication schemes. Inside that, we can pass the JWT bearer scheme. JWT bearer defaults authentication scheme. And for all the Web API methods, we are asking for the user to be authenticated to the system. Require authenticated user. And we have to finally call this method build. Sorry, we forgot to wrap everything inside a curly brackets like this. Now with this statement added here, for all the Web API methods, we have set the requirement that the user must be authenticated to the system in order to access any Web API method from this project. But there will be Web API methods like sign-in or user registration. They must be accessible to non-authenticated users. For that, we can make use of this allow anonymous attribute. So let's see how the Web API methods are responding with this statement added here. Let's build this project. Now, by the way, for each rebuild we do inside the Visual Studio, this Swagger UI will get reloaded and the previous JWT token that we have provided inside this authorization header will be lost. So at present, along with any of the requests, there is no token passed inside the authorization header. Now let's see whether we can make the post request for user login or user registration. See, we got the error for node 1 unauthorized. It's all because of this statement adding authorization attribute to all the Web API methods. Now let's see how to make Web API methods accessible for unauthenticated users. Inside this identity endpoints, we have Web API methods for user registration and sign-in. In order to make them accessible for unauthenticated user, along with this method invocation, we can change this method invocation allow anonymous, or you can make use of this attribute allow anonymous. For this entire series, I will stick with attributes instead of methods. So let me remove this and let's copy paste this same attribute for this sign in method also. Build the project. Let's make the request again. See, we are not getting the previous unauthorized error. Now we have to deal with this third type of web API methods. Before getting into that, I want to show you how to retrieve the claims of a signed in user. For example, inside this application, we have already created this getWebAPI method for user profile. Let's discuss how to retrieve the signed in user claims and how we can make use of them. Inside the sign in operation, we have added the payload containing the claims of the user. For example, at present we only have this claim for user ID. As a result of successful authentication, we have passed the JSON token back to the column. And then from there onwards, we'll pass the JSON web token to access any protected resource, like we have done with the getWebAPI method for user profile. Now inside the user profile, we want to know how to retrieve the claim that we have added to the JSON web token during the successful authentication process. Now that's the job of auth middlewares. Now, like we have already discussed, when we make a request for accessing a protected resource along with JWT token inside the authorization header, before the request reach its destination, the auth middleware will verify whether this JSON web token is a valid token or not, based on what we have configured while adding the authentication middleware. Whatever we have given inside this token validation parameters will be taken into consideration for validating the token, like we have already discussed. And when the JSON web token is successfully verified, the auth middlewares will decrypt or unpack the JSON web token into claims principal. Remember, while creating the JSON web token, we have passed the claims inside the JSON web token payload. During the process of verifying the JSON web token, the reverse will be happening. From the JSON web token payload, the claims will be populated with the corresponding values. So in order to access the authenticated user claims inside this user profile web method, we can make use of this claims principal. Now in order to access the same claims principal, we just need to add this parameter here, claims principal. I will name it as user. So the value of this claims principal instance will be injected through dependency injection because of the service that we have added here. Along with adding the authentication services, here we have added the authorization services. It will add a dependency injection for the claims principal. And that's how we are able to access this claims principal inside this web API method. Now we can retrieve the user ID that we have added into the JSON web token during the successful authentication. So here we go. I'll create this variable user ID. Let's access the claims property from the user object. It's an enumerable collection of the claims that we have added to the token. From that, we can invoke this method first, and here we have the lambda expression to filter the user ID. X type is equal to user ID. Make sure to pass the same name that we have given while adding the same into the token. And we want to retrieve the value of the claim. Now instead of returning this dummy string here, I want to return the user profile details with the user ID that we have retrieved here. For that, we can make use of the user manager, which is of the type app user. I will name it as user manager. So here we go, user details. From user manager, we can invoke this method find by ID async. Inside that, we can pass the user ID that we have retrieved from the claims principal. Since we have an async method here, let's prefix it with this keyword avoid. At the same time, this async keyword will be added to this method here. So we want to change the return type of this method as task iResult. Now let's return the user details inside the response. Results.ok. From that, we want to return an object like this. Email is equal to user details dot email. There is a possibility that this user details is null, so I will add this question mark here. Let me duplicate this. Now let's retrieve full name. Let's build this project. Back to the API Explorer. First of all, we have to add the JSON web token into this text box that I will copy paste from this notepad. Now let's make the GET request for user profile. Boom. So that's how to retrieve and make use of the claims of an authenticated user. Now let's head over to VS Code and let's see how to make a request from Angular to a protected Web API endpoint by passing the saved JSON web token. To demonstrate the same, I will make a GET request to this user profile endpoint and I want to display the full name of the logged in user inside the dashboard. For that, first of all, I will modify this app structure by adding this service class user. Inside that, we will do the operations related to the user other than authentication. Now let's create this service class user. So open the terminal, ng, g for generate, and we want to create the service class inside the shared folder within the folder services. And we want to name this service class as user. Hit enter. So here we have the newly created user service class. Now to make the GET request, first of all, let me inject the HTTP client. Now I will define this method getUserProfile. Inside that, we can make the GET request like this. HTTP.get method can be called. Inside that, we have to pass the URL of the endpoint. And this GET request will be returning an observable like we have done inside the auth service class here. We'll be returning the observable back to the caller. Now we have to pass the URL to this GET method. Inside this auth service, we have hard-coded the base URL like this, and for each HTTP request, we have appended the respective path like this. Now hard-coding this base URL is not a good practice. For that, we can make use of the environments folder inside the Angular app. So here is the folder and file that we are going to add into this application, environments. Inside that, we can create environment files for each execution mode of the app. By default, there are two files, environment.ts for production and environment.development.ts for development mode. Now in order to create this file, we could do this. Let's open the terminal. You could see the respective Angular CLI command inside this reference, then CLI reference, then go to ng generate, and here we have the environments. Let me copy this and pasting the same inside the terminal, hit enter. So here we have the new folder environments. Inside that we have those two files like we have mentioned here. Now as you can see inside this terminal, along with creating these two files, there is an update operation inside this angular.json file. Now we can discuss the update inside this angular.json file in a bit. So first of all, I will open this environments file, environment.ts. Into this constant object environment, I'm going to add a property API base URL. Into that, we can assign the base URL of the web API that we have saved inside this auth service. So here it is. Let me copy paste the same into the new property. For now, I will just copy paste this object into this file environment.development.ts. Now to retrieve this property value, we could do this environment. We have to import this object environment like this without mentioning the extension of the file, environments/environment. From that, we can access the base URL like this. Now for this user profile GET request, we have to append this /user profile. In a bit, I will tell you the benefits of using these files from the environments folder. Before that, let's do the same changes inside this auth service. We don't need this base URL. Instead, we can retrieve it from the environment file, environment.api base URL. Let me copy paste the same for this post request for the sign in operation. Now this is what is happening behind the scene. While creating the environments folder, I told you that there is an update inside this angular.json file. Inside this JSON file, if you search for file replacement, you could see this array here. So this is inside this object build. At present, this app is running at development environment, which you can see inside this object serve. Then inside this default configuration, you could see development. When we make this app public, we will change this configuration into production. So inside this file replacement array, you could see that when we are in development mode, this path here will be replaced with this file here. So inside the development mode, when we refer to the environment file, here we have imported from the environments folder, we have only mentioned it as environment, which file is not mentioned inside this import statement. That will be determined from this replacement configuration here. So this is a necessary requirement in the app development. During the production stage and the development stage, the configuration data will be different depending on the environment that we are running. In case of the production environment, instead of localhost, we'll be hosting the web API somewhere in public domain. So hope you understood how to make use of environment files and how to avoid hard coding the app config data. Now back to the method user profile. Now let's make use of this method inside this dashboard component. For that, we can implement the ng-onInit lifecycle hook. Implements onInit. Now it is necessary to define the method ng-onInit. Now in order to make use of the method that we have just created, we have to inject the user service into this component. So private user service of the type user service class. Now inside the ng-onInit lifecycle hook, we can invoke this method getUserProfile. So here we go. From this user service instance, we can invoke this method getUserProfile. This method will return an observer, so we can subscribe to that here. Into that, we can pass an object having this next and error callback. Inside this error callback, we will just print the error object like this. Error while retrieving user profile. Now, if the request is successful, inside this response, there will be the full name of the current user. So in order to save the full name, I'm going to create this property, full name. Now inside the success callback, we can assign the value from the response. Response.fullName. Now let's show this full name inside the dashboard component. Inside the component, we are already showing the logout button. Now let me add a wrapper div having this text sender div. So everything inside this div will be placed at the center of the web page. Now let me move this logout button into this div. Just below that, I want to show this h1 element having this bootstrap class display 6. Inside that, we will show this welcome message. Now let me duplicate this h1 element for showing the full name. Inside that, we can show the full name like this, full name. I want to make this text extra bold and let's change the text color. Let me save this, back to the app. See here we have the welcome message, but we can't see the full name. Let's open the developer console. See here we have an error for node 1 unauthorized. This is much expected because unlike the HTTP request that we have made so far from this auth service, this post request for sign up and sign in can be done without being authenticated to the system. But that's not the case with this user service method getUserProfile. In order to access this user profile endpoint, the user must be authenticated to the system. To prove that, inside the request header, we want to pass a valid JSON web token. For that, we can do this. Let's create an object of request header. Into that, we can assign an object of HTTP headers. Inside that, we can pass the authorization header. Authorization is equal to, like we have already discussed, we have to use this prefix bearer, and then we can pass the JSON web token that we have saved inside the local storage. I think inside the auth service, we have not yet created a function to return the saved JSON web token. So here we go, get token. Now let's return this saved JSON web token like this. Now instead of repeating this statement inside this logged in method, we can invoke this new method get token. Now back to the user service class. First of all, we have to inject the service class auth service. Sorry, here we have a typo, constant. Now let's append the token like this, auth service dot get token. Now all we have to do is just pass this header instance into this get method as a second argument. So here we go,
headers is equal to request header instance. Save this, back to the app, boom, that's it. Now we don't have the 401 unauthorized error. Now even if you're passing a valid token to consume the Web API endpoints, there might be situations where the Web API will be returning 401 unauthorized error. For example, when the token is expired, you will get the error 401 unauthorized. How to easily handle such situations will be discussed at the end of this video. Now, for accessing any protected Web API endpoints, we have to pass the JSON Web Token like this. In order to avoid repeating this operation in multiple places, we can make use of Angular Interceptor, which acts as a middleware. So this is what I'm gonna do. Inside the app structure, into this shared folder, let me add this interceptor, Auth Interceptor. We have already created this environments folder. Now let's create this Auth Interceptor. So open the terminal. You could see the respective command inside this CLI reference, then ng generate interceptor. Let me copy this and pasting the same here. We want to create the Auth Interceptor inside this folder shared, and we want to name it as Auth. Hit enter. So here we have the newly created interceptor, Auth Interceptor. Now this will act as a middleware. So all the HTTP requests will go through this Auth Interceptor. For that, first of all, we have to register this interceptor inside the app config file, app.config.ts. While invoking this method, provide HTTP client. Inside the method, we want to invoke this method with interceptors. Into that function, we have to pass an array containing the new interceptor that we have created, Auth Interceptor. Now back to the Auth Interceptor. Now by default inside this method you could see that this next method is invoked by passing the request object. So by default this interceptor does nothing. Whatever request comes, it hand over the request as it is for the next step. But now we have to modify this interceptor to append the saved JSON Web Token along with the Web API request. So first of all, we want to check whether the current user is already logged in or not. For that, we have to inject the auth service. So here we go, auth service. Let's invoke this method inject. Into that, we have to pass the respective service class, auth service. From that, we can invoke this method is logged in. If that's the case, first of all, we'll create a cloned object of this request received at this interceptor. So here we go, cloned request. To clone the object, we could do this request.clone method can be called. At the same time, if we want to modify any of the properties inside the request, we can do that. So this is the right time for modifying the authorization header. So here we go, headers is equal to request.headers.set method can be called. Here we can pass the JSON Web Token inside the authorization header. So let me copy paste that from this user service. Let's copy this and pasting the same here. Auth service.getToken. We have to pass the key value pairs like 2 arguments. So instead of colon, use comma. Now from this auth interceptor, we can pass this modify request for the next step. So here we go, return, and we have to invoke this method next. Inside that we can pass the cloned request. Now from here onwards, in order to access protected Web API endpoints, we don't need to repeat this operation in each of the places we make the request. All of the requests will be gone through the HTTP interceptor. If the user is already logged in, we'll append the user JSON Web Token like this. Else, we'll propagate the request as it is for the next step. Save this, back to the app, reload the page. It works perfectly fine. Now we can discuss the third type of Web API methods. Apart from authenticated to the system, these Web API methods have criteria defined with role, claim, and policy. Now to discuss the rest of the topic of this video, consider we are creating a Web API project for an educational organization. So first of all, we have role. Most often, the organizational designation will be treated as the role. No need to explain much. In whatever organization you are, your role or your designation determines your permissions, your responsibility in the organization.
So conventionally, ASP.NET Core Identity Framework has been treating role as a different property to be considered for authorization purpose. Now considering the example project, we could have the roles like admin, teacher, student, etc. And then we have claim. You could think of them as pieces of information about the user. So any information other than the role will be treated as a claim. For example, user ID, which we have already added to the JSON web token, then age, gender, then the class or grade in which the student is studying, then library ID, etc. And finally, we should be familiar with the term policy. You could think of them as a criteria defined with role, claim, and when we want to combine roles and claims, there will be a logic in between them to connect each other. For example, admin only means only the user with the admin role can access the particular web API method. Then we have admin or teacher, female teachers only. All of these policies will be defined and corresponding web API methods will also be created in rest of this video. So without further ado, let's get into it. So first of all, let's look into this user table columns. We have user ID, user name, email, then password, phone number, then full name, which we have added through the app users model here. And rest of these columns are created corresponding to the default properties from this identity user model. Now we have to add columns corresponding to these claims here. And along with that, we have to add the role. As I already told you, the ASP.NET Core Identity Framework already treated role as a different entity inside the identity framework. As a result of that, inside the DB you could see a separate table for roles. Into that, I will directly add the roles that we have seen here: admin, teacher, and student. In a real-world project, you will be having web API methods to implement the correct operations over the entity role. But in order to save the time, I will directly add the roles into this SQL Server table. So here we go. First of all, we have admin. Inside the normalized name, just enter the capitalized version of role name. Then we have teacher. Finally, student. Now I will show you how to assign these roles to the users that we create during the user registration process. Before that, let me add few more properties to the user table corresponding to these claims here: age, gender, and library ID. For that, I will modify this model for app user. First of all, we have the property corresponding to the gender. Then we have date of birth from which we can calculate the age. And finally, we have the library ID. Now in order to add the respective column into the SQL Server table users, we have to do the migration. So first of all, let's build this project and make sure there is no error. We have a successful build. So open the package manager console. Let's do the migration. Add migration. I will name the migration like added gender, date of birth, and library ID. Finally, we have to execute this command update database. Back to the DB, refresh the tables. Let's expand this ASP.NET users columns, date of birth, gender, and library ID.
Inside this table, we already have two users added from the previous sections.
Now for better clarity, I would like to remove those rows here. So here we go. Delete from the table. Execute. That's it. Now let's update the user registration web API method accordingly. So here we have the method to handle the post request for the user registration process. First of all, let's change this model to receive the data that we send through the post request. User registration model. Into that, I want to add these properties: role, gender, age, and library ID. For the sake of explaining this topic, instead of using the date property for date of birth, I have used age. Okay. Now inside the method create user, let's feed the data into respective SQL Server tables. As you already know, there is no property for role inside the user table. So if we want to assign a role from this table rows into a user from this table users, we have this table user roles. The corresponding user ID will be added to this column user ID, and the corresponding role will be added to this column. I will show you how it is done from the Web API part, and then we can see how it is added in the respective table. For that, after creating the user, we can assign the role like this. It's an async operation, so I will prefix it with this keyword avoid. From this user manager, we can invoke this method add to role async. As a first argument, we can pass the user object that we used for creating the user. Second parameter should be the role that we want to assign to this user, that we can retrieve from the user registration model role. Now, in order to work with roles, we should add the respective services into this project. Along with adding the handles and stores, here we have added the entity framework stores. So let's add the services related to roles. Here we have to specify the model that we use for roles. We are using the default model from the identity, that will be identity role. For user, the default entity is identity user, but we have customized it into app user. But for the entity role, we have not made any customization, so we'll use the default entity from the identity framework. Now back to the user registration Web API method. So this will assign the role passed to this Web API method for the newly created user. Now in order to feed the data for rest of the properties while creating this user object here, we can assign the properties like we have done for other properties here. Gender from gender. Now for the property date of birth, from the current date we are minusing the years as much as age we pass to the Web API method. And finally, we have assigned the library ID like this. So this is all the modification we need for the rest of the discussion. Now I'm going to create different users having different values of role and claims. To make the process even more simpler, I'm going to add a JSON file to this project folder directory. Add new item, and I will select this template for JSON file. Let it be user details. Inside that, I will paste an array of objects corresponding to the users that we want to create, so that it would be easy for you to do the same what I am doing here. So first of all, here we have a user with the role admin, and rest of the details are here. Now build the project. Let me copy this object back to the API Explorer, and here we have the post Web API method for sign up. For the user we are about to create, there is no library ID. So rest of the properties will be like this. Now click on execute. Boom, that's it. So here we have successfully created the user, and you should see the same in the respective SQL Server tables. First of all, we have the users table. So here we have the new user, and inside this user rows, you should see the admin role added to the new user. See, here we have the user ID for the newly created user ending with C28, and we have assigned the admin role for this user. So this role ID should be the ID of the admin role inside this roles table. See? So that's how this table users rows connect both the entities user and role. Now like this, we have to add rest of the users. So to save time, I will pause the recording of this video and I will be inserting rest of these users here. Now finally, I'm done with adding all the users. Let's re-execute the select query for users. So in total, we have added 7 users. Now instead of selecting all the columns, let's select only the columns that we really care about. Let's execute the select query again. Let me order the result based on the column full name. From these users' full name and email address, you could know what is their role, what is their gender, what is their age, all of that. So at present, we have 1 admin, 2 teachers, 1 female teacher and 1 male teacher, and 4 students. 2 male students and 2 female students, and out of which only 2 students is having library ID. If you check the user roles table, you could see that all the users are assigned with respective roles. Now, before going forward, I want to make few updates inside the Angular client side while making the post Web API request for the sign up or user registration. because we have added few more properties into this user registration model. As you can see here, these properties, role, gender, age and library ID, are the additional expected data for creating a user. So here we have the user registration form. Apart from these form control data, we have to pass the data for the newly added property inside the web API. So back to VS Code, then open auth service. Inside that we have made the post request for the user registration. So first of all, I will add this warning here. Here we are passing default value for role, gender, age and library ID. Now for the sake of explanation, here we are just passing the default value. We are not adding any respective form controls inside the front end. I will leave that up to you. Either you can change this sign up form into a multi-step form for feeding the data for these extra properties, or you can create a separate page or separate component to feed the data. For now, I'm just hard coding the default values like this: role, gender, age, and this property library ID is optional. So from now onwards, if you are using this interface here, behind the scene you will be creating a female teacher with the age 35. Now back to the web API. Now you know what we have to do. When any of these users get authenticated to the system, we have to save these information, role and claims into the JSON Web Token payload. Then only these informations will be available for defining authorization criteria. Remember, when a user successfully authenticated to the system, we generate the JSON Web Token. And all the necessary information should be added to the JSON Web Token payload. So whenever we try to access a protected resource with a JSON Web Token, during the process of validating the token will be decrypted or unpacked into the claims principal. And whatever we have inside this claims principal can be used for defining the authorization criteria. So back to Visual Studio, let's update the sign-in endpoint. Inside the method with these two statements, we will find and assign the user into this user object if there is a user with the given email and password. Now inside this if clause, we have all the details of the user from this users table. And along with that, we need the role assigned to the particular user. For that, we can do this. We will have this object roles, and we can invoke this method get roles async from user manager. Inside that, we just need to pass the user object. Since we have an async method, just prefix the invocation with this avoid keyword. Now, like we have added this user ID claim, we need to add few more claims. So what I'm going to do is, I will just cut this and I'm going to assign the same into a variable of the type claims identity as claims. Now we can add the necessary claim. First of all, we have gender, then age that I will calculate from the date of birth. And finally, we have to add the role of the user. Instead of using a string as a key for the claim, we have to pass this role property from the claims type. And here we have assigned the role that we have retrieved here. Now along with these claims, I also want to add the library ID as a claim. Not everyone has a library membership. So I'm going to do this. If the user has a library ID, we can add the corresponding claim into the payload. So here we go, claims.add claim. Inside that, we can provide an instance of the claim like we have done here. Library ID. From the user, we have to assign the property library ID. While defining this model property here inside the app user itself, you could see that we have defined it as nullable. And for the same reason, you could see this green squiggly line here saying that this property is nullable, so you cannot expect always a value from this property. Since we have added this if clause here, we can ensure that this claim will be allocated with a proper value. So in order to ignore this warning, all we have to do is, as a suffix, we can add this exclamation mark. That's it. Now we can pass this claims identity object claims into this subject here. Let's build this project. Back to the API Explorer. Let's try to log in with a user that we have just created. For that, I will make use of this JSON file, userdetails.json. We only need to copy this email address because this much portion of the email address is given as the password for all the users inside this collection. So here we go. So this is the admin user and here is the password. Let's make the request. Boom. Let me copy the token. Now let's go to the official website for JWT authentication and just paste the same inside the debugger. We have already discussed how to make use of this debugger interface in previous video. Just paste the token here so that you could see what's inside the payload. See, we have all the claims that we have added from the login WebAPI method. User ID, gender, age, role, etc. So all of these are available inside the claims principle to define the criteria for authorization. Now what I'm going to do is I will just copy this JSON web token and I will add the same along with this object here. I will add a new property called token and let's save the token that we have got with a successful authentication for the user here. It would be helpful to test the WebAPI methods that we are about to create. Now let's see how the payload of the user having the library ID. Let's copy the email address. Here we have the email address and here is the password. Let's make the request. Here is the token. Let's copy this and pasting the same inside this debugger. Boom. Along with other claims, you could see the library ID here. Now let's copy this token and let's append the same to the respective object here. Now like we have added these two tokens for these two users, let me do the same for rest of the users also. It will be necessary for testing the configuration of authorization in various WebAPI methods. So a successful token for every user is added into this JSON file here. Now in order to define authorization criteria with role, claim and policy, I'm going to create a new C# class file for demo endpoints. I will name it as Authorization Demo Endpoints. Let's change this class into static. Now let me copy paste this method for map endpoints. Let's rename this method to map authorization demo endpoints. Let's invoke this method inside this Program.cs file. Now let's see how to define a WebAPI method accessible only for the users having the admin role. So here we go. We have an endpoint admin only. I will handle this request inside this method admin only. And let's define the method here. For now, from this method, we are only returning this string admin only. Now, if you want to restrict this WebAPI method only users having the role admin, you can do this. First of all, we want to add this authorize attribute. Into that, as an argument, we can pass the criteria like this: role is equal to admin. So whenever a user tries to access this endpoint, the middleware will verify the user has an admin role, else the request will be denied. Let's build this project and let's test the new endpoint. For that, first of all, I'm going to use the JWT token of a student. Copy it and back to the API Explorer and let's paste the same here. So here we have the new WebAPI method that we have just added. API/admin only. Let's make the request. Boom. We got the error 403 forbidden. Do you remember when you tried to access the second type of WebAPI method here, if you are not authenticated to the system, the response status code was 401, meaning unauthenticated, meaning that you don't even have a JSON web token. Now we got a server response with the status code 403, meaning that you are authenticated to the system but you don't have the required permission to access the WebAPI method. Let me show you that once again. Just clear the JSON web token and just try to access the WebAPI method again. See, this time we got 401. So that's how the status code works. Now let me try to pretend as a user having the role admin. So that will be the JSON web token of the first user. Let me copy this and let's set it as the bearer token. Let's make the request again. Boom, we got the status code 200, meaning everything went successful. And here we have the proper response from the WebAPI method. Next we have to check whether the user is having either admin role or teacher role. So here we go. Let me copy paste this endpoint. The corresponding route will be something like this, admin or teacher. Instead of defining a separate private method here, I'm going to make use of a lambda expression like this. For now, we will just return this string admin or teacher. Now, like we have defined the authorization criteria here, we can add the attribute authorize. Along with admin users, we also need to consider users having the role teacher. That's it. Sorry, instead of adding the authorize attribute here, we just have to give it here as a prefix to this lambda expression. So that's how we can define authorization criteria using only roles. Now, if you want to make use of claims or a combination of claim and role, you have to define a policy, meaning a separate criteria should be defined inside the project. That we can do while adding the authorization service. Along with defining this fallback policy, we can define policies like this. Options dot add policy method can be called. Now let me define a policy with this name has library ID. So this is the name of the policy. And as a second parameter, we can pass the condition or criteria with a lambda expression with this parameter policy. All we have to do is we just need to check whether there is a claim library ID. As you already know, inside the users that we have created, there are users without a library membership. So we want to check whether the user is having the claim library ID. We can check that by invoking this method require claim. So we will check whether the user has the claim library ID. Make sure that the same name is used while saving the same into the JSON web token inside this sign-in method here. Library ID, make no mistake, the same should be provided here. So here we have created a policy or criteria called has library ID. Now we can make use of it while defining authorization criteria. To save time, I will just copy paste the WebAPI method here. So here we have the URL of the WebAPI method, library members only. As the name suggests, this WebAPI method should only be accessible for users having the library ID. So here we have given the authorization criteria with the policy that we have just created, has library ID. Let's build this project. Now let me copy a token of a user having no library ID. Back to the API Explorer, just set it as the bearer token. Since we have defined the method with lambda expression, you could see them under the name of the project, which is Auth API. So here is the newly created WebAPI method, API/library members only. Click on try it out and let's make the request. See, we got the error 403 forbidden because the current user does not have a library ID. Now let's try the same with a user having library ID. Send the request. Boom. We got the status code 200 and we got the proper response from the WebAPI method. Now in order to create WebAPI methods having these requirements, let me add few more policies. Let me copy this and pasting the same below. I will name this policy as females only. So instead of checking whether there is a claim gender or not, we want to check whether the claim gender is having the value female. For that, as a first parameter, we can pass the name of the claim And then as a second parameter, we can pass the value that we want inside the gender claim. Okay, female. Now along with the gender value female, if you also want to consider other values for this claim, for this criteria, we can pass them one by one after the female value here, like gender 1, gender 2, so on. Okay. Now finally, let me define one more policy for users having the age under 10. So I will name the policy as under 10. In order to define this criteria, we want to check whether the age of the user is less than 10. The comparison cannot be done with these methods here. For that, we'll make use of this method require assertion. Inside that, we can pass a callback method with this lambda expression having the parameter context. Inside this context, we have this object user. Inside that, we have the claims, which is corresponding to the claims that we have added into the JSON web token. From that, we want to check the value of the claim age. So here we go. X time is equal to age, and from that we want to retrieve the value. In order to convert this same into an integer, we can wrap this entire property with this method invocation int 32.parse. So this much portion will give us the integer. Now we want to check whether it is less than 10. So here we go. So these are the policies that we need for defining web API methods having these authorization criteria. So let me save this and back to this demo endpoints. Now here we have the get web API method for applying maternity leave, and it is only applicable to female teachers only. Inside this authorized attribute, first of all, we have set the requirement that this is only for users having the role teacher, and they also must satisfy this policy females only. So this is how we can combine roles or policy or claims for defining authorization criteria. Let me build this project and let me copy the JSON web token of a teacher, male teacher, and let's set the same as the bearer token here. Let's try to apply for maternity leave. See, we got the error forbidden. Now let's try the same pretending we are a female teacher. So here is the user. Let's copy this token and let's provide it here. Let's make the request again. Boom. Now finally, I want to define a web API method for females under 10. So here we go. Under 10 females. For that, we have used two policies. Policy under 10. So the user must be having the age under 10 as per the policy that we have created here. This policy. And along with that, the user must be having the policy females only. So when we apply authorized attributes separately with the policies, both the condition must be satisfied. So only female users having the age under 10 can access this web API method. Build the project. Let's pretend to be a user having age under 10 but he is male. See, student, male, having age 9. Let's copy this token. Back to the API Explorer. Let's set the bearer token and let's make the request. See, we got the error forbidden. Now let's try to pretend a female student having age 9. Boom, that's it. Now let's head over to Angular client side and let's implement these authorization using role, claim and policy. So first of all, what I'm going to do is I will create Angular components corresponding to these endpoints which we have used for demonstrating the web API authorization. So back to VS Code, let's open the terminal. So in total we have to create 5 components. So here we go, ng, G for generate, C for component, and we want to create these components inside a folder called Authorized Demo. First of all, we have admin only. Hit enter. You could see the newly created component here. Now, the reason for using the same name as that of the endpoint inside the web API is that we are assuming that inside this component we have some admin only operations. So we'll restrict this component only to the admin users. Same is the case with the rest of the components that we are about to create inside this authorized demo folder. Now let's create the next component, admin or teacher. Apply for maternity leave, library members only. Finally, under 10 and female. So these are the 5 components that we need for demonstrating the authorization inside the Angular client side. Now since we have made a lot of changes inside this web API, first of all build the project. Now back to the app. If you are already logged in, please log out, because inside the web API we have added few more claims into the JSON web token that we needed for demonstrating the authorization. So in order to retrieve the newly added claims inside the client side or inside the JSON web token, we have to re-log in into the application again. Now let me log in with admin credentials. Now, before implementing the authorization inside this Angular app, I want to configure the routing of this app to include newly added components, and we also need navigation links to navigate the routes. So back to VS Code, and let's open the routes file app.routes.ts. All of the routes that we are about to add for these new components inside this authorized demo are protected routes. So the respective route must have this property can activate assigned with this auth card. And this auth card will only allow the authenticated user to access the route. So let me copy paste this dashboard route object for the new component admin only. So here is the path admin only, and the respective component will be admin only. And we need this can activate property assigned with auth card. Now similarly, let me add the route object for rest of the components. So here I have added the routes in this similar order: admin only, admin or teacher, apply for maternity leave, library members only, and finally under 10 and female. Now you can try any of the routes that we have added by directly entering the routes like this: admin or teacher. And you could see the default paragraph from the newly added components. Now for all the routes that we have just added, and for this dashboard, we want to show a top nav bar and a side menu. And into the top nav bar, we can move this Logout button. And inside the side menu, we can show the different nav links corresponding to the routes that we have added. For that, what I'm going to do is, I will add a parent route object like this, like we have added for this sign in and sign up routes. So here we go. Path will be an empty string, and then we have to provide a component, and that will act as a layout component. So here we go. First of all, we have to create a layout component. So open the terminal. We want to create a component, and that should be created inside a new folder called layouts. And we want to name the component like main layout. Hit enter. So here we have the new folder layouts. Inside that you could see the component main layout component. And here is the corresponding HTML file. We can add the top navbar and side menu in a bit. First of all, let me add this router outlet. Router outlet. Now, it is necessary to import the same inside the component TypeScript file. Now, let me update the app structure. We have just added the layouts folder. Inside that, we have the newly added component main layout. Now, back to the routes configuration. Now, for this parent route, I will set the component as the main layout component. Now we can add these routes as a children to this parent component here, like we have done here. So here we go, children, which is an array. Now let me cut these routes from here. and let's put them inside this array. Now each of these routes will be shown in place of this router outlet here. Besides this, we'll be adding the top navbar and the side menu in a bit. Now one more thing. All of these routes are made protected with the same guard, auth guard. So instead of passing this can activate to all the children routes, we can pass it through the parent route object like this. Can activate is equal to an array containing the auth guard. Now we can remove this auth guard from the children components like this. So we made these children routes as protected by setting the can activate to the parent route object like this. Now back to this main layout, and let's add a top navbar and a side menu. After that, we can protect these Angular routes based on the role or claims assigned to the signed in user. First of all, I will add a div having this ID main, and inside the div, first of all, we'll show the top navbar, and just below that we have to show the content of the route. So let's move this router outlet into it. To add the navbar, let's go to the official documentation of Bootstrap and let's search for navbar. Then go to this section, nav. I will copy this navbar here, this one. Let's copy this back to the layout component and let's paste that just above this router outlet. At present, this is how it looks like. First of all, I want to leave a space for the side menu, so I want to add a left side margin for this top navbar or the entire main div here, this one. So open the global style sheet and let's set this margin left to 240 pixel. Now let's move this logout button into this top navbar. At present, it is inside the dashboard component. Let's cut this. Then back to the main layout. Let's paste that just after this search form. Now we also have to move the click event. So back to dashboard component TypeScript file. Let's cut this back to main layout and let's paste that inside this component TypeScript file. Now we have to inject the necessary services. For that, back to dashboard component and let me copy paste this constructor into the main layout. Let's import this router and this auth service. For now, we don't need this user service. Now let me add few more padding to the top navbar like this. On horizontal axis, we need a padding of the range 5 and that of the vertical axis will be of the range 1. And we have to do the same for the content of the route. For that, we can add this wrapper div having these clauses. Let's set the maximum top margin and from all the sides we will add a padding of the range 5. Now let's move this router outlet into it. That's it. Now for the side menu, we can do this just before this main div. We can have this nav having this ID sidebar, and let's apply these bootstrap clauses. Navbar, we want to set the background color with this clause and we'll assign the entire vertical height to this sidebar, and here we'll set the flex direction to column, and finally we have to assign this clause justify content start. Now open the global style sheet, styles.css. Inside that, we'll modify the appearance of the sidebar like this. We have set the position with these 3 properties, and here we have set the width to 240 pixel, which is the exact margin that we have assigned to the main content. Okay. Now let me remove this app name or brand name from this top navbar, and we can show that inside the side menu here. For that, we can have this div having these bootstrap clauses container fluid, justify content center, and let's apply a padding of the range 1 from all the sides. Inside that, we can have this anchor element to navigate the dashboard. So let's apply these bootstrap clauses. Navbar brand h1 typography. Let's make the containing text bold. Let's change the text color to success, and let's apply a bottom margin of the range 3. Instead of this href attribute, we have router link having the path /dashboard. And here is the anchor text auth EC, which is the name of the app. Now in order to make use of this router link, first of all inside the TypeScript component, we have to import router link. So here we go. Now just beneath that we can add nav links for each of the components that we have inside the app. For that, back to the main layout component HTML, just below the anchor element, we can have this unordered list having these bootstrap clauses, nav, and then we will set the flex direction to column, and let's allocate the 100% width, and let's apply a horizontal padding of the range 3. Inside that, here we have the list item having this bootstrap clause nav item. Now let's add the anchor element for the route admin only. So here we have the anchor element having this bootstrap clause nav link. Instead of href, we have router link assigned with the path /admin only. Now let me copy paste this for the next route, that will be admin or teacher. Admin or teacher. Inside the first anchor element will show this text admin only, and that of this will be admin or teacher. Save this back to the app. So this is how the nav links looks like. In order to customize their appearance, let's update the global style sheet. So here we have changed the appearance of the menu items, and here we have the mouse over effect. And this is the final result. Now at present we are logged in with an admin user. So both of these routes should be accessible to this user. Now suppose if the logged in user is a student, then we should prevent the user from accessing both the routes. So let's check how to protect an Angular route based on the logged in user claims or roles. That we can do with Angular guards. So here we have the auth guard. Inside that we have already denied unauthenticated users from accessing protected routes. Now to implement the additional criteria based on the user claims or roles for each routes that we have inside this route configuration, we have to specify the criteria that we want to check before allowing the user to access the route. That will be different for different routes. For example, this route can be accessible for admin users, and this should be accessible for anyone having the role either admin or teacher. So first of all, inside the respective route configuration object, we will make use of this property or object data. Into that, we can pass an object like this. Now to implement the feature, I'm gonna pass a callback function like this, claim requirement. So through this property, I'm passing a callback function having a single parameter c, which refers to the claims of the user. And inside the callback, we just need to check whether the user has the role admin. You will get a clear picture once we reuse this callback inside the auth card. Now let me copy paste this inside this admin or teacher route. So for this route, the user must have either admin or teacher role. So here we go. Role is equal to admin or teacher. Now before passing the claim requirements for rest of the routes, let's head over to auth card and let's see how to make use of these callback functions. Before moving forward, let me tell you this. The term claim refers to any information about a user. So while we are outside the web API, the term claim is also referring to the user's role as well. Now inside this auth guard with this if clause, we only allow the route access to authenticated users. Now the additional claim requirements that we are about to impose are only applicable to the already logged in users. So instead of returning the true right away, we'll check whether the user passed the claim criteria given by the activated route. So first of all, inside this if clause, we have to retrieve the data that we have passed inside the route object. So here we go, claim requirement is equal to, we can retrieve that from this route parameter. Route.data, so with this property data, we can retrieve the data that we have passed here. From that, we have to retrieve the property claim requirement, and we want to convert that as a function because we have passed callback functions into the property claim requirement. Now if there is a callback function passed to the claim requirement property, meaning that this route has certain claim requirements, else we'll return true. there will be such routes. For example, if you have a route or a component for changing the user password, such a route should be accessible to anyone authenticated to the system. So in those cases, for such routes, we will not be passing a claim requirement callback function. Okay, you will see that in a bit. Now in order to execute this function, remember we have this parameter claims, which is corresponding to the logged in user claims. Inside that we are checking whether the currently logged in user has the role admin or whether it is having either of these roles, admin or teacher. So first of all, inside this if clause, we want to retrieve the claims of the currently logged in user. So here we have the constant claims. Inside this auth service, we should define a function to return the claims. So here we go, get claims. So like we already discussed, the user claims will be the second part of the JSON web token. The JSON web token is saved inside the local storage. So first of all, let's retrieve the saved token. We already learned that the JSON web token has 3 parts and all of them are separated with a dot in between them. So let's split the token string based on the character dot. So this will return an array, and from that array we want to retrieve the second element, so the respective index will be 1. We are talking about array index. So the second element index will be 1, so that is referring to the payload of the token, or in other words, the claims of the currently logged in user. Now like we already seen, the payload is actually encoded into the second part of the JSON web token. So we'll decode that with this method which we have already seen, window.atob. Now you could see this error due to this warning that this method getToken may return undefined. We could say that it won't happen because before invoking this method, we are making sure that the user is authenticated. So in order to avoid this warning, instead of this question mark, we can pass exclamation mark. Now the output of this function atob will be the stringified version of the claim object. In order to convert that into a proper JSON object, we can invoke this method JSON parse. So that's what we return from this method getClaims. So that's a proper JSON object having different claims assigned by the server API for the currently logged in user. Now back to the auth card. Let's invoke the method auth service.getClaims. Now inside an if clause like this, we can invoke the callback function like this, claim requirement. Into that we can pass the claims that we have just retrieved. Now all of the callback functions that we are passing to the claim requirement will return a boolean value based on the requirement that we are checking here. Hope you already know that here we are using the shorthand version of the arrow function syntax. This is the actual full function. Since we only have a single return statement, we can minimize it like this. And that's what we exactly done for this callback function also. So if the user met all of the claim requirements, this function will be returning true. Now if the function is returning false, meaning that the user does not met all the claim requirements, in that case, we'll be redirecting the user to a route having the path forbidden. The corresponding component or the route is not yet created, and finally we have to return false. If the user has met all of the claim requirements, we'll return true. Now let's create a component for this route path forbidden. So inside the app structure, first of all, let me add the component folder like this. So we are going to create this forbidden component. So open the terminal and let's create this component forbidden. So here is the new component forbidden. Now let's update the route config. We'll add the respective route object into this children array of this main layout. So here we go. Let me copy paste this forbidden, and we want to render this new component forbidden. Now let's update the forbidden component HTML. Instead of this default text, we will have this div having this class text sender. Inside that we can have this h1 element having this bootstrap class display1. Inside that we will show this message oops. Let's duplicate this h1 element, change this class to display6. Inside that we will show this status 403 permission denied. And with this additional paragraph, we will show this you don't have the permission to view the page. So we have created the forbidden component and we have designed it and we have configured it with the route path forbidden. Let's save this, back to the app. Now at present, these routes admin only or admin or teacher is accessible for this admin user. See? Now let's try the same with a teacher account. So I will select this first teacher, email and password. Now the current user is a teacher, so this route admin or teacher should be accessible. But this one should not be accessible to the user, admin only. But to our surprise, this teacher can access this route admin only. How it is possible? It's all because of applying this can activate to the parent component. So at present the auth card is getting executed only when the parent component is getting rendered. And the claim requirement callback functions from the child routes are not reaching or getting executed in the auth card. If you want to trigger the auth card for the containing child components here or the child routes, we have to pass the auth card to the property can activate child. Okay? Now it works perfectly fine. See? Now let's move on with the next possible restriction based on the user claims. Normally, if a route is not accessible for currently logged in user, we hide the nav link or any navigation leading to the particular route, like this admin only. For this teacher user, this route or the corresponding component is not accessible. So why don't we hide this nav link? Now to do that, we are going to make use of Angular directives. You could see the official documentation here, directives. So back to the app structure, I'm going to add the new folder called directives. Into that, we will be adding this directive, custom directive, hide if claims not met. You could see the respective Angular CLI command here. CLI reference ng generate directive. So open the terminal and we want to create this directive inside this folder directives. So here we go, g for generate, then d for directive. We want to create that inside this folder directives having this name hide if claims not met. Copy this and pasting the same here, hit enter. So you should see the directive here, directives hide if claims not met. Now the custom directives that we create will have this prefix app, and that of the inbuilt directives will be ng. For example, ng if, ng for, ng switch, etc. Now this is how we are going to make use of this directive. Just copy this selector and then back to the main layout. We'll assign the directive to the respective list item like this. Now into that we'll be passing a callback function like we have done inside the route config, specifying the claim criteria which the user must be met before showing the respective HTML element. Now to make use of this directive, first of all inside the TypeScript component we have to import the same. So here we go, hide if claims not met. Now back to the directive. Now based on the claims we'll be deciding whether we want to show the li element or not. That we can do inside the ng on a lifecycle hook. Similar to Angular components, ng on a lifecycle hook is there inside the Angular directives. So here we go, implements on init. Now it is necessary to define the method ng on init. Now in order to receive the callback function that we have passed here, we can add an input property, input, and we'll be using the same name as that of this directive selector here, meaning that we are directly assigning the callback to this directive here. So this name should be used for the input property here. And inside this directive, we'll name the function as claim requirements set as optional property having the type of a function. Now inside the ng on a lifecycle hook, first of all we have to retrieve the logged in user claims. So here we go, claims. Now we have to inject the auth service. So here we go, private auth service of the type auth service class. From that we can invoke this method get claims. Now like we have done inside the auth card, we'll invoke the method claim requirement callback function. Into that we can pass the user claims like this. Now if it is not met, we want to hide the respective li element here, this one. For that, first of all we have to inject the instance of element ref. So here we go, element ref of the type element ref. So inside this object we'll be having the DOM element corresponding to the li element. From that we can access the respective HTML element and we'll change the style display to none, and thereby the respective li element will be hidden. Now here we are not yet passing a proper callback function, so let's copy paste that from this route config. Now don't bother about the syntax error here. Going forward with the app development, if there is any change in the claim requirements, we have to update this callback function in this file and this route config, actual route config file here. So that would be a problem. So this is what we are going to do. We are going to create a separate TypeScript file. Inside that we can define all of the callback functions for verifying the claim requirements. So this is what we are going to do. We are going to create a new folder called utils. Inside that we can create this file, TypeScript file, claim requirement utils. So here we have the new folder, utils. Sorry, this should be inside the folder shade. So let me move this to this shade folder. Inside that we can create this TypeScript file, claim requirement utils. Now here I'm going to create a constant object called claim requirements. Inside that we'll define all of the functions like admin only, admin or teacher, and we'll be exporting this constant like this, export constant. So first of all we have the function admin only. Now let me copy paste the function definition from this route file here. Let's cut this and pasting the same here. Now like this we need admin or teacher. Now back to the route config. Let's cut this function and pasting the same here. Now we can make use of these callback functions to verify claim requirements wherever needed inside this Angular app. For example, inside this route config we could do this claim requirement, which is from this folder utils, and from this file claim requirement utils. So this is the exported object. From that we have to pass this function admin only. Now for this route admin or teacher, we have to pass the function admin or teacher. Now in order to use the same function inside this layout, first of all inside the TypeScript file of the component we have to import the same. So import, we are inside the layouts folder, so let's exit from that. Then go to shade. Inside that we have the folder utils. Inside that we have the claim requirements utils. From that we have to access claim requirement object. Now we can make use of this object inside the template file here, claim requirement dot admin only. Sorry, just importing this object is not enough. We have to create a property with the same name like this, claim requirement. Into that we can assign the imported claim requirement here. Fine. Save this, back to the app. Boom. See, the respective li element of the admin only route is not visible. Let me log out and log in with the admin user. Boom. These nav links are shown because the current user can access both of them. Now let's do the same for rest of the routes. First of all, I will add the respective claim requirement functions here. Has library ID. Here we just need to check whether the user claims has a property library ID or not. So here we go. We will check whether the property library ID is inside the object or the claims object. And then after that we want to check whether the user is female and a teacher. So here is the function. Gender is equal to female and the role is equal to teacher. Finally, female and below 10. So here we go. Gender is equal to female and we have passed the age into an integer and we have checked whether the age is below 10. Now back to the route config. Let me copy paste this data for rest of these routes. Now for this route, apply for maternity leave, we want a callback function to ensure that the user is a female teacher. So pass the function female and teacher. And then we have this route for library members only. The respective function will be has library ID. Let me copy paste the same for under 10 and female, and the respective function is female and below 10. Now open the main layout. Let's add the respective nav links. Apply for maternity leave, then library members only, and finally under 10 and female. Into each of these li elements we have passed the directive with the respective claim requirement function. Save this, back to the app. At present we have an admin, so only these two nav links are accessible. Let's log out. Let's log in with a female teacher. Only this one is accessible. Why not this one? Female and teacher. Sorry, for this route admin or teacher we have not yet assigned this directive. Let's copy paste that here. Admin or teacher. Anyway, this menu item for applying maternity leave should be accessible to the current user and for any female teacher. So what happened? Sorry, there was a problem while passing the claims from our web API. In order to see the actual problem, you could do this inside this directive. Let's print the returned claims like this. See, inside the return claims object, see, the recommended naming convention for claims is camel casing. But inside the web API, we have used Pascal casing. Inside this Angular app, we have used the camel casing. See, library ID, gender, but inside this claims object returned from the web API, we have Pascal casing. So let's change that inside the web API. So first of all, let's open this identity user endpoints, and inside the sign-in endpoint, here we are passing the user claims. Let's change this to camel casing. Before that, first of all, we should find all the places we use the Pascal casing. For that, we can make use of the find utility, and let's search all over the current object, and let's find all of the places where we have used this name user ID. So first of all, inside the controller, while retrieving the user profile details, so let's change that to camel casing. Let me copy this, and then here we have the property user ID. That's not a problem. And then inside this sign-in endpoint, and then we have inside the migrations. That is different. Let's skip that. Now let's do the same for gender. Let's search all over the project. This is inside the user details JSON object. Let's skip that, and then we have this sign-in endpoint. Let's change that to camel casing. Let me copy this, and then we have the same while defining the policy here. Let's update it here. Now back to the sign-in endpoint. Next we have age. Let's find all over the project. First of all, we have inside this sign-in endpoint itself, update it to camel casing. Let me copy this, and then we also have the same while defining the policy here. Back to the sign-in endpoint. The role property is already in camel casing. Finally, we have to update this one, library ID. Let's search, enter the project. Let's select this match case option to avoid irrelevant results. First of all, we have inside this sign-in endpoint itself. Let me copy this. Then we have, while defining the policy, has library ID. Then we have inside the migrations. That's not a problem. Let's build the project in order to reflect the new changes. Back to the Angular client side, logout. We must log out in order to receive the updated claims object. Let's try login again with the teacher account. See, here we have the updated claims object. Boom. Now we are showing all the routes which are accessible to the current user. Let's try login with a student account. This user has a library ID and is a girl below age 10. So both of these nav links are shown. So that's how to protect a route or a component based on the claim requirements. Now we are not done yet. Now suppose inside this dashboard we have a button and that can only be accessible for an admin user. How can we do that? So open the dashboard component. Here we have the button having these bootstrap clauses btn, then btn danger. Inside that, for now we'll just show this text, some admin operation. Now we only want to show this button for admin users. So what I'm going to do is, we can make use of this directive here, this one. Let me copy paste this directive of the list item of the admin only hyperlink. Now to make use of this directive and this claims functions, we have to import the same inside the TypeScript component here. So let's import the directive hide if claims not met, and then we have to import the constant like this shared /utils/ claim requirement utils. From that we want to import the object claim requirement. Now let's create a property with the same name. So here is the property and let's assign the imported object into it. Let me save this back to the app. At present the currently logged in user is a student. Let's try with an admin. Boom. How cool is that? Now finally I want to show you how you can handle request responses having the status code 401 unauthenticated, 403 forbidden. It could happen. At present we have hidden or restricted the access to a component or a route or a button like this if the currently user does not have the necessary permissions. But there could be situations like token expiration or because of some malpractices by the user, the web API will be returning request responses like 401 or 403. So we have to handle that properly inside the Angular app. We could do that inside the auth interceptor. Inside that we are already passing the JSON web token if the current user is already logged in. So this is exactly a middleware. All of the requests pass through this interceptor. So at present this is what we are doing inside the interceptor. If the user is already logged in, we will clone the request by assigning the authorization header with the respective valid token of the user. And then we have propagated the same cloned request with this next object. Now to handle the 401 and 403 request responses, we just need to tap into the observable returned from the next method. So here we go. We can invoke this method pipe. Inside that we have to invoke the function tap, which is from RxJS. Into that we can pass an object like this. Into the property error we can pass a callback having a single parameter error of the type any. Inside that we will check the status codes 401 and 403. If the status code, let me rename this parameter to this one. If the status code is equal to 401, we will handle that inside this if clause. So 401 corresponding to unauthenticated user, meaning that don't have a valid token. The token that we have passed here is not valid or it is expired. Now the token that we have saved inside the local storage is not valid. So first of all, let's delete that, and we want to redirect the user back to the login page. So first of all, let's inject the router from Angular. Now here we go, router dot navigate by URL /signin. Now along with redirecting the user, I want to show a toaster notification. So let's inject the toaster service as toaster. Now we want to show the toaster notification once the sign in page is rendered. So we will add a small delay, so we can invoke this method set timeout. Let it be 1.5 seconds. After that, we will show the toaster notification with info method. So the toaster will be having the blue color. Inside that, we just need to show this. Please log in again. And the title will be something like this: session expired. Now instead of a 4.1 status code, suppose we are getting a 4.3 error, we could handle that inside this else if block like this. We just need to show the toaster notification saying that, oops, it seems like you are not authenticated to perform the action. Now let me show you what happens when you get this 4.1 status code. For that, we just need to consume the web API when the token is expired. So what I'm going to do is back to the web API, then inside the sign-in endpoint, here we have set the expiry time of the token as 10 days. Let's change that into 1 minute. Now we also have to change how we want to validate the JSON web token. That we can do inside this identity extensions. Here we have defined how do we want to validate the JSON web token. First of all, we want to set this property validate lifetime. By default it is false. Let's set that to true. Now in order to avoid considering the time standards, we can set this clock skew to timespan 0, timespan dot 0. Let's rebuild the project. Back to the app, logout, try login again. Now inside the dashboard, we have made a request for the user profile to retrieve the full name of the user. Now try reloading the page after 1 minute. Boom! That's it. So that's it guys, we have discussed all about implementing authorization in an Angular app with ASP.NET Core Web API using various permission requirements like claim and role. Please comment below your feedbacks and how you want to extend this series further with features expected in an Angular auth system.
So that's all for this video. Please consider subscribing to the channel if you haven't yet. Please like and share this video with your friends and colleagues so that they can also benefit from this. Have a nice day. Bye.